Good morning, everyone. Welcome to the December meeting of the Federal Communications Commission's Technological Advisory Council, or TAC as we call it. My name is Dean Brenner, and I'm the chairman of the TAC. For those of you who are watching online who may not be familiar with the TAC, we are a group of outside advisors appointed by the chairwoman of the FCC, Jessica Rosenworcel, to give the FCC the absolute best advice on important technological issues. Our charter was established in writing at the beginning of the year. We're a federal advisory committee, and so pursuant to the Federal Advisory Committee Act, we are working in working groups to fulfill our charter and to come up with a set of actionable recommendations for the FCC, which would be finally adopted by the TAC before the charter runs out, which is in September of next year. Our only motivation here is to provide the absolute best advice to the FCC to advance the interests of the United States on important technological issues. It's been my honor to chair the TAC for the past 3 years. You're going to hear today from our 3 working groups, which are advanced spectrum sharing, artificial intelligence and machine learning, and 6G. When I was appointed to chair the TAC, Chairwoman Rosenworcel emphasized the need for the TAC to focus especially on 6G. 6G is in the middle of its formation, which is a multi-year global process, and of course we want to ensure that the interests of the United States are fully represented and accounted for as that process plays out. But of course, 6G is not the only thing we do, and 6G has ramifications much beyond just 6G cellular. So spectrum sharing, of course, is a very important topic that comes up in spectrum management here at the FCC and at NTIA and other federal agencies. Artificial intelligence, machine learning is a very important topic just because the way the FCC is organized, we don't have a bureau of AI, ML, but AI and ML are now becoming so prevalent that their impact and ramifications touch on many, many different things that the FCC does beyond just the narrow docket issues, the way the FCC looks at things and does its work item by item. So thank you to everyone who's at the table and online participating in our meetings. Again, for folks who might not be familiar with the TAC, we are all volunteers. Nobody gets paid for doing this. Some of us have different outside interests, some who we are representing here, and all of that is publicly disclosed the way the FACA Act requires. But again, our job is to give unbiased advice, and thank you to everyone who's come today and participating online. This meeting, a quarterly meeting, is always the culmination of a huge amount of work that's done in our working groups and supported by our great FCC staff, some of whom are here, some of whom are online, and they spend a lot of time steering us in the right direction, making sure that our work is as helpful as possible to the FCC. So with that, let me turn things over to my good friend Ira Keltz, who's the acting chief of the Office of Engineering and Technology, for any remarks Ira would like to make.
All right. Thanks, Dean, and welcome. Good morning, everybody. So this is my actually first TAC meeting as acting chief, so it's kind of not probably momentous, but will be interesting nonetheless. I'm not going to repeat what Dean just said, but just want to reiterate, the importance of the work and the various working groups. All 3 are extremely important, and and we rely so much on the work that the TAC does. And I like to think of it as you are helping us, but what that does, it helps us to help you. And by you, I mean the larger telecom industry as we go about our work to figure out how best to make sure we have the right policies in place to make everything work as good as it can and keep the U.S. At the front of this industry. So don't want to take up any more time because I really want to hear the presentations. So with that, I'm going to turn it back to Dean. But thanks.
Thanks a lot, Ira. I will now turn things over to our great designated federal officer, Martin Duxett.
Yeah, so I'd also echo thanks for all the progress working toward the items in the charter. It's been a substantial amount of work that's happened up until the end of this calendar year here. And as we progress toward the end of the charter in September of next year. Just a couple of quick logistics. For folks that are on the Teams meeting online, if you can remain with your video off and muted when you're not speaking, and turn the video on and microphone on likewise when you are, that would be appreciated. As far as questions and discussion, we're going to have the presentations followed by hopefully some questions and discussion for each of the working groups. I would ask folks on the Teams call to use the hand raise feature so that we know that you have a question and we can turn it over to you. I'll be monitoring that. And also in the room, if you can turn your name cards sideways so that we know that your hand is raised in the room, we can monitor that as well. Besides that, I'm looking forward to productive discussion today and working toward actionable recommendations for the end of the charter. And I'll turn it over to Sean if he has any other additional remarks. Thanks.
I just wanted to echo thank you. It's been already a year since we all started working on this charter, so really want to thank you, echo that as well, and looking forward to the presentations.
Okay, great. So we will start with a presentation from our Advanced Spectrum Sharing Working Group. So I'll turn things over to Monisha and Andy.
Thanks, Dean. Thanks, Martin and Ira and Sean. Are the slides coming up? Okay. Good morning, everyone. So Andy and I, we co-chair the Advanced Spectrum Sharing Working Group, and we'll sort of tag team on the updates, as well as have some of the Spectrum Sharing Working Group members present their conclusions or preliminary recommendations that we're working on. Just a comment, we actually have had about 9 months to work on some of this, and we're looking forward to closing out on these items in the next season. Next slide, please. Next slide.
Is your clicker? You have a clicker?
Oh, I have the clicker. Sorry.
There we go.
Thank you. I have to do the work. And I clicked too fast. Okay. We have a very robust attendance in our working group meetings. We meet every Tuesdays at 3 p.m. Pretty much the entire TAC membership is part of this working group, and we have close to 30 people attending each of our meetings, and the complete list is there. Good representation from all sectors of stakeholders, the wireless industry, the WISPs, the Wi-Fi, plus a couple of academics as well. In addition to the considerable expertise that we have within the group from our various members, we've also had subject matter experts come and present to us on certain topics. So Mike Marcus, he's actually a member of the group as well. He gave us a presentation on coexistence and spectrum sharing above 100 gigahertz. And this topic touches a bunch of charter items, which we will go through in more detail. We had David Willis and Steve Leach from Ofcom telling us about what they are thinking about cellular Wi-Fi hybrid spectrum sharing in the upper 6 gigahertz in the UK, and that actually touches upon more or less all of the charter items we had. We had Dinesh Bharadia from UCSD talking about some of the research that he's been doing on looking at how the network topology can impact energy efficiency, and this was very specific to charter item 9. Billy Kozma from ITS and Mark Walker, Cable Labs, gave us a really nice presentation on clutter and propagation loss. All spectrum sharing at some point or the other depends on trying to find out, who's going to interfere with whom, and propagation models are extremely important in figuring that out. And Doug Hyslop from CTIA had a very interesting talk on 3.7 gigahertz band and radio altimeters and some of the recent advances in filtering that addresses the problem. We also had another talk that isn't mentioned here. It came rather late in the season, was from DARPA. They have a program called COFFEE. It's Compact Front-End Filters at the Element Level, which talks about what you can do on receivers to improve performance. So most of the preliminary recommendations you'll see are based upon analysis of opportunities and challenges at bands below millimeter wave and terahertz, since those bands require pretty different technical assessments. And that topic will be explored in much more detail in the coming months. So I will run through briefly the first 5 charter items. We had 10 of them, so that was a lot of work for the group. And we divided up the charter items in a way that people could take leads on preparing white papers and the preliminary recommendations that you will see. So most of what you'll see today, most of the charter items that have preliminary recommendations also have white papers that are near final, but we didn't go through the final approval process, which we hope to work early in the next tax season. So the first charter item was, what will advanced sharing frameworks and architectures look like in the future? This is led by Amit Mukhopadhyay from Nokia. And what we are going to do with this charter item is present some preliminary recommendations based on the discussions and the white paper that we've been working on. Charter item 2 asks about spectrum sharing models, how they will adapt and evolve to meet the growing demand for spectrum access among various services to support multiple purposes. How can the interplay between terrestrial and satellite be complemented in sharing models to promote more efficient spectrum use? This is also led by Amit. We have preliminary recommendations in draft form, which we will not present today. And this topic, in addition to being charter item 2, is also related to some of the other charter items. Charter item 3 is really about propagation models. To what extent can the FCC optimize the propagation models that they use to reflect less conservative and more realistic assumptions and support more intensive sharing while still protecting against harmful interference? Are there specific bands where improved propagation models offer a pathway to liberalize performance capabilities beyond what the FCC permits today? This has been led by Dave Gurney, Motorola, and we've had a couple of SMEs present to us. And today, Dave will present near final recommendations based on the work that the group has done. Charter item 4 is how can we better facilitate spectrum repurposing efforts, address intraband and interband issues and address them early in the process? How can incumbent services be better informed about what's happening in adjacent or nearby spectrum? And how can users be encouraged to take steps needed to accommodate new spectrum in these environments? We've also looked at what can we do regarding adjacent band spectrum, wide receiver bandwidths. So this also has a relationship with charter item 5. Tom Sawanabori from CTIA and Roger Nichols from Keysight were the leads on this. They've been working on looking at what has already been done in some of the bands, recent bands, and Tom will present the outcomes of that. These are going to be near final recommendations based on a white paper that we have in the group. Charter item 5 is really specifically looking at current state of the art in receiver technology. What can we do with active antenna arrays, filters, to reduce both intersystem and intrasystem interference, things like beamforming, null steering, cost-benefit advantages of utilizing what we have today versus what we can work on in the future. I and Dale Hatfield from Silicon Flatirons lead this charter item. And we've had some discussions with SMEs and had with relevant projects in other parts of the government like DARPA. This item is also related to other charter items, as we show here, 1, 4, 7, and 8. What we propose to do with this charter item over the next year is really do an in-depth survey of what the current state of the art is in receiver technologies, where programs like DARPA, which are very, very far in the future, what they are doing, and how we can have a projected timeline of when some of these developments in research and R&D can find their way into commercial products. So I will hand this over to Andy to take us through the rest of the charter items.
All right, thanks, Manisha. So continuing on with just a high-level summary of the last 5 charter items. Charter item number 6, what are the candidate bands or services that can coexist with low-power indoor-only operations such as factory automation, and what are the sharing mechanisms to consider there? Jason Jackson from Kyndryl has led that effort, and he's going to have some initial conclusions on this combined with agenda item 8 very shortly. Charter item number 7, what are the sharing considerations for services above 95 gigahertz? So millimeter wave into the terahertz region, and that would include sharing with passive services, which is a challenging issue, and they're also very big users of spectrum at these higher frequencies. Jason is also leading that. We haven't done that much on that to date. We will begin working on that coming up, and we also now have the expertise of Mike Marcus from Northeastern, who's also very well aware of a lot of the issues for millimeter wave and terahertz spectrum. Charter item number 8 that Jason's going to combine with charter item 6 here in a minute. What role should sensors play in informing spectrum use and in supplementing spectrum sharing databases? So we'll be addressing that and have some initial thoughts there. Charter item number 9, what are the trade-offs between efficient spectrum use and environmental considerations, including sustainability and energy efficiency? If you haven't looked at the kind of power that a typical 5G base station consumes, it's very eye-opening. And so obviously addressing sustainability and energy efficiency is important. Rob Alderfer from Charter has been leading that, and he is going to have, I wouldn't exactly call them recommendations, but he's got some initial thoughts and considerations on the energy efficiency aspect. We've had a subject matter expert come to speak to the group about that, so he'll be presenting here in just a few minutes. Rob will. And then finally, charter item number 10, what methods can support the Commission in identifying spectrum bands that have the most potential and flexibility for sharing and repurposing? What are the candidate bands and which bands should be prioritized? How should those bands be combined or separated for federal and/or non-federal uses? What are the optimal coordination processes between stakeholders to better support implementation and consideration of these methods? So that's just a very small inquiry right there. So Michael Cataletta from Scientel, who's here, and myself will be addressing this more in the coming months. We don't have anything that we're presenting today, but this is a very important and very large topic that the group will be considering. So that's a very high-level overview of the 10 charter items that this group is addressing. It's kept us very busy for the last 9 months. It will keep us very busy for the coming 6 months or 7 months. So we'll be working on that. But let's turn now to the 5 items that we actually have some preliminary either recommendations or considerations for. We added in here, by the way, before we get to that, a chart that, a lot of these are interconnected. A lot of these charter items have, they're not completely independent from one another. So we sort of put together a matrix that shows the connections between the different charter items, and that's how we're dealing with them in the group. So charter item 1, this was led by Amit, who is here in person, and he has some thoughts and initial recommendations. So let me pass it down to Amit.
Thank you, Andy, Manisha. And even though I'm presenting the results, there are many contributors to this effort. So without naming each one of them individually, I certainly express my thanks and gratitude to all the efforts that have gone into this topic. This is the main question there was, what are the emerging frameworks and architectures, right? And as you can imagine, this is a very, very wide and broad topic, so we had to make it as focused as we can so that we could actually make some progress there. In terms of the background, we wanted to focus on specifically inter-system spectrum sharing, meaning that in general, as we see, there are many, many users of the spectrum, and whether it's licensed, unlicensed, federal, non-federal, and each one of them is asking for more spectrum because new applications are coming up. On the other hand, the desirable part of the spectrum is pretty much occupied. There is no more spectrum that is freely, that could be made freely available to the users. So we have reached a situation where sharing the spectrum has become pretty much inevitable. On the positive side of things, there are numerous advancements happening in the engineering and scientific world, especially in the context of evolution of AI/ML-based techniques. And we see that spectrum sharing is becoming more and more a feasible and perhaps even attractive solution. With that in mind, the first thing that we wanted to do is set some ground rules. First of all, what do we mean by spectrum sharing? If you look at different organizations all over the world, they use the term in so many different ways that it's very easy to get confused by just the term spectrum sharing, from 3GPP spectrum sharing to NTIS dynamic spectrum sharing to many other definitions. So for the purpose of this group, we adopted a simple definition from NIST, which said spectrum sharing as a way of optimizing the use of airwaves or wireless communications channels by enabling multiple categories of users to safely share the same frequency bands. It's a very simple, generic definition that we could all agree upon. Then we had to, as I mentioned before, we had, in order to make meaningful progress, we had to select a couple of specific scopes so that you don't go all over the place. We focused on inter-system spectrum sharing. And by that, I mean, if it is intra-system, for example, say between licensed operators or licensed technologies, we did not want to focus on those things. But where FCC can really play a role, where they bring in diverse set of users. So our primary focus was on inter-system spectrum sharing. Secondly, the most interesting part, at least important part for immediate use, is the lower part of the spectrum. In particular, we looked at below millimeter wave and specifically 4 to 24 gigahertz, rather than doing a very broad search of all the possible ways of spectrum sharing. So these are the two ways we kind of narrowed down the scope of our activity so that it could be more relevant and also most efficient way we could operate. Secondly, we wanted to have a discussion about what do we mean by successful spectrum sharing? How do we even characterize it? And we came up with a few guiding principles that we should aim to achieve in order to do spectrum sharing. First of all, service assurance. The primary concern about spectrum sharing is the availability of vital resource when the service is needed. And if I can't get the spectrum when I need it, then obviously confidence in spectrum sharing is going to fall below what we want. So we want to make sure that the spectrum is available when it is needed. And you also understand that the level of concern among incumbents and also the new entrants, if we may say, depending upon what service they deliver, that level of concern may be different. But one thing, the key thing is service assurance is a very, very important criteria for spectrum sharing. Secondly, infrastructure reuse. Many of the users have been already in place, an infrastructure for using the spectrum currently. And the ability to reuse that existing infrastructure is very important. If a system user had to build new infrastructure or add additional infrastructure, that adds to the cost of their use of the spectrum, and that is not a very desirable way to do so. As far as possible, all the users should be able to reuse their existing infrastructure. Number 3, maximum reuse of the spectrum. I think this is quite obvious. So from a practical perspective, the incumbents are using the spectrum, but anytime if they have priority, anytime that they're not using the spectrum, new entrants should be able to use that without any, say, meaningful gap, both geographically as well as temporally. The maximum use of the spectrum is a very, very important thing. And last but not the least, just as the new entrants are adopting to use the spectrum developing technologies, incumbents also need to evolve their technologies, because spectrum sharing by definition is a two-way street. All the responsibility should not be falling on the new entrants. Incumbents also need to evolve their system. With these broad criteria, we now go into the main topics of the charter. First, we talk about the candidate frameworks for spectrum sharing. What would be the frameworks with which our next generation need of spectrum sharing might evolve? When you're looking at the candidate frameworks, first of all, we do want to learn from the existing ones, established ones, and then we also want to learn the future one or the new ones. On the left-hand side of the chart, what you see are more or less established ones. For example, contention-based spectrum sharing technology is typically used with the unlicensed spectrum bands that you're familiar with. Number 2 is enhanced coordination system-based evolution of CBRS-SAS or 6 GHz AFC, how they could be evolving. These are more incremental approaches. And the third one, overall, as a framework, we know federal, commercial, or federal commercial sharing. We have seen that quite a bit between federal commercial sharing. We know that, or even commercial in CBRS and 6 GHz, these have been technically quite successful by different measures, but you also have to need about their viability from a commercial perspective in a long-term manner. Now, if we look at the future possibilities, we identified 4 main topics. One is inter-system signaling based. Let's say there are multiple users of the spectrum, and if there is a mechanism that they can exchange signals among themselves and inform each other when one is emitting versus the other is not, and how they can balance each other. That's one framework that he talked about. The second one is indoor-outdoor based. So maybe one system operating indoor, the other system operating outdoor, and they figure out a way to share the spectrum from a geographic perspective, but with the caveat of indoor-outdoor kind of environment. The third one is interference threshold cross-reporting based. So one system experiences some level of interference, but it is beyond the agreed upon interference level, and it reports And this is where we plant the seeds of a closed loop mechanism. And I'm going to expand upon it a little more, but think of a closed loop mechanism being as the two systems are giving feedback to each other and correspondingly adjusting each other's transmission so that they can actually coexist or share the spectrum in a cooperative way. And the last one in this category is transmitter identity-based sharing. So each transmitter is broadcasting some identity with which the aggressor or victim can identify who is causing interference beyond what has been agreed upon and then can take appropriate action. So these are the more candidate frameworks that we think would be interesting to investigate upon. And then we talk about emerging technologies for spectrum sharing. What are some of the emerging mechanisms that we can use? There are a few, starting with propagation models. These are continuing to evolve, improve, driven by ability to better tailor them to real-world propagation effects, local conditions, and so on and so forth. These are pretty much progressing from a model-driven statistical technique to a much more data-driven entities which may utilize also AI/ML-based techniques, and they become much more efficient in forecasting what kind of mitigation techniques would be needed and so on and so forth. Secondly, digital twins are also expected to have a significant impact on spectrum sharing, where we can actually foretell what the impact will be, mimicking the actual environment and managing the interference based on the digital twins. Third is spectrum sensing capabilities. There are a lot of improvements happening in this context. Spatial processing and improved spatial reuse. Spatial processing that allows us to mitigate, share the spectrum in a much more efficient way. And last but not the least, KPI feedback. So one system could figure out how its performance is being affected by another user of the spectrum. It can provide feedback and again develop a cooperative system. This also feeds into the closed loop mechanism that I mentioned before. With that, we go to the say near final conclusions. This is almost ready, but yet to be fully agreed upon by by the owners of this charter and the reviewers. So two things that we wanted to highlight in terms of the conclusions. First of all, techno-economics. The essential criteria for successful spectrum sharing have a common theme around the economic impact. There are two aspects of it. The sharing conditions need to be such that the users of the sharing spectrum can deliver their service in a cost-effective manner, so all the users must be able to benefit from it. Furthermore, the sharing solutions themselves must be economically viable to build and operate. Otherwise, even the greatest technically effective solution may not get implemented in practice. Thus, the overall economic impact of any sharing solution needs to be carefully evaluated. Secondly, we are talking about the closed loop systems. All current frameworks are essentially open loop. There are no feedback mechanisms among the different users who may be considered victims or aggressors. That typically results in overly conservative protection criteria, which ultimately means inefficient use of spectrum. A closed-loop framework, if we can build it, on the other hand, can create an environment where users exchange real-life interference information and mutually collaborate to protect each other while maximizing spectrum use. Going to the final one. This is of the recommendations that are coming from this group. The first one we're talking about, for a specific spectrum range under study, we need to be fairly focused, otherwise you can go all over the place. establish a multi-stakeholder group comprising relevant academic, federal, and commercial representatives, NSF, SMAC, CT, NCT, etc., for reaching consensus on key technical requirements for all users. It is understandable that some of this information may be sensitive. In that case, arrange for a relatively small group of experts to have the right level of security clearance so that they can actually discuss these things openly and freely and arrive at the right technical solution to begin with. Second one, for FCC to get involved with SDOs, standard development organizations, and also there are proprietary solutions in the space of spectrum, and all of them have to be brought together. Thirdly, if it is spectrum sharing among, say, commercial entities, for example, 3GPP, Wi-Fi, etc., FCC can play an active role in, again, bringing those entities together, bringing the SDOs together to work towards a common solution. And last one is continue the practice of spectrum-related rulemaking that is technology agnostic, while ensuring all potential users of the spectrum evolve their technologies and guided by a common set of rules to enable most efficient use of spectrum. Again, to emphasize, it should not be only upon the new entrants, even the incumbents also need to evolve the technology. The Commission should continue to avoid regulating CBRS GA users beyond what is already done. Let the industry figure out how to best use the spectrum, evolve technology, and make the best use of spectrum by developing the right sharing technologies. That's what I have from my side. Thank you.
Thanks. I'm wondering, I haven't spoken to Andy and Monisha in advance about how you'd like to do this. That was a spectacular presentation, Amit. Thanks so much. And there's so much in it. I'm wondering if we should stop now and ask for questions or comments before we go to your next presenter. Does that make sense?
Yeah, probably a good idea. Maybe time for one or two questions if anybody has any.
Yeah, exactly. Does anyone have a question or comment, either in the room or online? Donna, we'll start with you online.
Hi, thanks everyone, and apologies for not being there in person. I wanted to be. This is a great group. The one comment I am making, and I've made this in the subgroup and in writing, is I think that our group on sharing should not dive too much into economics and into that direction, but if we do, we need to sort of balance that out with the other points, such as, you know, what the public good is. And I agree, both services should be able to evolve. But again, I think just we have to be careful and about when we're talking about economics and the technical advisory committee. Thank you.
Okay, thanks. Henning?
Yeah, good morning. A kind of related issue that I think deserves additional discussion is the one about the level of trust, not just during the discussion, as was mentioned, during the standardization, but also during the operation in that. And I believe that often shades the what happens if somebody misbehaves. Can I remove that entity from operation, for example, reasonably, or can I prevent the entrance of devices that may not conform to that imported on the gray market, for example, in that. So that to me is another kind of fundamental aspect that may prevent technologically feasible solutions where just the level of trust of the actors is not there. And in some cases, it's easier if you have a smaller number of entities, like CBRS probably falls into that, versus the consumer market, where it's obviously very difficult to police 120 million households in that. So I wonder if that's one item that I think deserves further discussion.
Any comment on that, Amit?
Sure. I agree with Henning. We should not only look into the initial implementation, but ongoing operations and how we can improve. I think that is indeed an important aspect that should be considered for spectrum sharing. With respect to Donna's comments, I understand that we in FCC TAC may not do a lot of evaluation. However, I think it is incumbent upon us as TAC to advise FCC that economic aspects cannot be completely ignored. We cannot be just fully focused on technical aspects because at the end of the day, if the economics does not make sense, the technical solution will not be implemented. That would be the market force. And it is that context that we are suggesting that not only technical, but also the economic aspect of it, please look into it to have the overall meaningful impact on the broader society.
Thanks. Anyone else in the room? I have two comments, quick comments. The first is I did smile at the notion that sharing based on indoor use versus outdoor use is some futuristic new thing. Of course it is. Monish is shaking her head, right. That's been around as long as I can remember. The original 5 gigahertz rules had an indoor-outdoor distinction. The original CBRS proceedings went around and around about that. So that is something that's always kind of in the mix. Of course, it depends upon the particular situation, which leads me to my second comment, which is, in my experience, I don't know if anyone disagrees with this, but in my experience, these sharing issues are typically dealt with band by band. And, there are a somewhat unique set of interests that are dealt with in each, and other considerations kind of in a band by band context, and that really has driven historically the outcome. I think you've done a great job of laying out kind of an overall approach, a more generic, band agnostic, if you will, approach to spectrum sharing, and having a mechanism. We have the CSMEC, we have the TAC, we have we have the IRAC, we have other mechanisms that are developed band by band. But I think having a more generic approach that there's widespread buy-in from, which will always be controversial because what you think about spectrum sharing depends upon your commercial interests in a particular situation. But I think having a generic approach the way you laid it out, including some kind of overall multi-stakeholder group, is a great idea, and I hope that that's something that is a recommendation that's moved forward. So thanks. Anyone else? Okay. We can move on to the next. Oh, go ahead.
So about your first point, you're absolutely right. The reason why I'm bringing it up, or why I'm bringing it up, is now it is really gaining traction around the world. First, the Ofcom came up in the upper 6 gigahertz, and that now it is pushing in CEPT. And yesterday, the Australian authorities actually made it an official declaration of indoor-outdoor sharing, especially in highly populated areas. So it is making progress in the right direction.
Thanks for
and
that.
Band by band, absolutely. There is, it all depends on the incumbents and the interest, and the solutions are going to be very different. And 100% agree with I think the first recommendation that we had. Yes, band by band. Thank you so much.
Thanks a lot.
Thanks, Amit, for that. We'll move on to the next charter item, which is charter item 3 on improved propagation models. And Dave Gurney, who led this item, will present. He's doing this remotely.
Yeah, good morning.
We will control the
Next one.
slides from
Sure.
here, Dave.
Yeah, thank you. Okay, so as mentioned, we're developing a draft report on this topic. It's obviously a large topic. It's never simple when you talk about all the variety of propagation models involved, but we tried to focus on some popular and applied propagation models, including ITU's irregular terrain model, HADA, and extensions of the HADA model, Okamura, TM91-1, Winter 2 models, and the like. So there's a wide range of models there. In general, not surprisingly, these models all have limitations and frequency bands they can cover, and whether they consider detailed terrain effects, terrain databases, and detailed clutter modeling effects, especially in the localized terrain of the transmitter and the receiver. In addition, these models are Sorry about
Dave?
that. I'm not sure when I got, I'm not sure when I got muted there. Not
Yeah,
sure
we
how I
hear
got
you
muted,
again.
but yeah. So I'm not sure where I dropped out, but in general, these many of these models are probabilistic in nature, and that adds some interesting dimensions for protecting incumbents. There's always a delicate balance between making more spectrum available and protecting incumbent services. We do suggest interference informed, risk-informed analysis of that, such that when you're protecting critical services or life safety services, obviously you want to be more certain that you're not going to cause interference. That's an important factor to keep in mind. Some of the very popular propagation models like ITM also could benefit from the incorporation of clutter modeling. That's actually being done today recently in the CBRS band. So we're incorporating P2108 clutter models for low antenna height base stations, taking into account additional system factors like transmit duty cycles, system loading factors, and using median propagation modes. That really helps to open up additional spectrum. I think in the case of the CBRS band, I think the statistic was you're allowing 72 more million users unfettered access to the band by some of those changes in the dynamic protection areas. So those are all very important developments. And then in addition, there's another important aspect is to continue along with these measurement campaigns to improve and validate the propagation models. Some good examples of that would be NTIA ITS's efforts in the midband in the 3 gigahertz range. The ISART 2024 conference focused on clutter modeling, and that's a very important aspect, as we mentioned. And there's also NASTN efforts going on to sort of validate the propagation models used in the CBRS band. In addition, there's a lot of sensing campaigns going on, crowdsourced data in cellular and other bands being developed. AARL as a very large database of measurements taken by that community for weak signals, reporting signal levels and signal to interference, signal to noise ratios, and that band across the world. Really, it's a very large database of millions of points, and incorporating that type of data, I think in the future will probably become more and more important. Amit earlier mentioned the possibility of integrating feedback mechanisms into those models to make it more closed loop, to refine the models as they operate. That's an area for future study that we'll be looking at. Next slide, please. All right, in terms of propagation bands where those models can be applied, as I mentioned, we've generally focused on the existing and perhaps potential future spectrum sharing bands. That includes the CBRS band, the 6 gigahertz band, 3.1 to 3.45 and 7.8 gigahertz bands. There's always developments occurring in these bands. There's been recent developments that I mentioned before in the CBRS band, improving that modeling. There's also been some recent developments in the 6 gigahertz band for building entry loss, incorporating some of those, I'd say, simplistic models initially. Further refinements are certainly possible in those bands. For example, in the CBRS band, perhaps incorporating additional clutter modeling for outdoor base stations. And we also intend to look at the millimeter wave bands and above 100 gigahertz going forward. And we're still fairly early on in this effort, so we haven't taken any final positions with respect to bands to apply. Next slide. Okay, so in terms of preliminary recommendations, we encourage the Commission to continue to refine the effectiveness of propagation models, including the incorporation of more realistic and advanced modeling techniques. The state of the art, continually advances in this area. You get more and more data. You might incorporate LiDAR data and things like that. There's a lot of developments going on in those areas. We also encourage the Commission to incorporate advanced clutter modeling techniques, including some of the ones that we mentioned above, and also incorporate the appropriate risk assessments in shared spectrum bands. Those also increase the accuracy of the propagation modeling and enable more coexistence among users, more sharing of the bands. And then finally, we encourage all parties involved really to continue to prove out the reliability of propagation modeling through real-world measurement campaigns and related studies. And that's an important aspect. Obviously, you want to verify what you fielded. One nice thing about centralized sharing mechanisms is that it's relatively easy to incorporate changes going forward in propagation models. So things like the SAS and the AFC and in those shared spectrum bands, you can sort of adapt those techniques over time. So there is some ability to do that in the field. That's where we're at today. We'll be finishing up this report in the coming year, focusing on the areas that I mentioned. Thank you. Any questions?
Dave, hey, thanks so much. That was also very well done. Questions, comments, either online or in the room? Henning?
Yeah, just one topic of discussion that I think would be important or that we raised, but I think deserves more attention is there's a applicability issue for models. Namely, one is how good is it just physically, and the other one is inherent kind of caution as to where it's just always going to be quite challenging to use propagation models. So, for example, I think it's quite reasonable to have better propagation model for fixed type of situations where both the incumbent and the new entrant are well known and in a fixed location, in typically small numbers. Think cell tower and radar, say, a fixed radar. But it's going to be really challenging, and we should probably add sufficient caution to our conclusions where we would want to extend that to mobile devices or devices whose exact location, such as what kind of indoor location they might find themselves in, think vehicle versus balcony versus basement, make any real propagation modeling going to be essentially pointless simply because we just don't know in that. So having a good sense of where propagation models are actually applicable and where they're likely not all that helpful, not because the physics are difficult, just because the knowledge is limited.
Yeah, absolutely agree on that. Certainly indoor, outdoor has been a topic of much discussion and discussion of perhaps refining some of those models as well, but it's always tough when you have mobile users and you're already dealing with probabilistic type propagation modeling. So agree.
Yeah, I had a similar comment as well, and actually it's something that could be incorporated into Amit's more generic framework, which is when the incumbents are fixed, I think sharing is a substantially different and should be less challenging issue than when the incumbents are mobile. And that applies in the case of propagation models and trying to figure out what the propagation is going to be in the band, who's really going to be using it if the users are mobile. Any other comments or questions? Okay, I think Tom, you're next. Tom Sawanabori.
Yes, good morning. And I'll be talking about the next section, which is on really spectrum repurposing, identifying some of the lessons learned and opportunities to better repurpose spectrum in the future. So we did a couple of case studies looking at bands sort of in the C-band and up to 6 gigahertz. This may or may not apply, to all bands, since higher bands, for example, could have different characteristics and with antennas and other technology. But we've looked at these 2 case studies, and we're also monitoring a third case study, so we'll talk about that in a minute. The first one we looked at to better repurpose spectrum and identify both inter and intra-band issues was the C-band. So that was in clearing of 280 megahertz between 3.7 and 3.98 gigahertz spectrum. And that was, a high priority effort that, involved repacking broadcast satellite spectrum into more efficient use of the 500 megahertz they were already using. Some of the lessons learned that came out of this, and there's a draft paper that we've developed, is that, altimeter performance was tested and evaluated, but should have really been done earlier in the process. Along those lines, the RTCA Aviation Standards Group specified improved filters, but could have done better, to specify better filter performance, which would improve the resilience to in both 5G receiver blocking as well as spurious emissions. The other multi-stakeholder groups worked very well together between the wireless industry and the FSS community, and of course financial incentives for accelerated clearing of the bands and so forth really helped with the overall business case to allow the satellite community to repack spectrum. Now what's really interesting is there's more opportunities in the upper C-band. And when I talk about the upper C-band, I'm meaning between 3.98 and 4.2 gigahertz, which is just below the altimeter band. This is currently being utilized by satellite broadcast, but it's interesting to note that SES has also already announced back in April that they plan to acquire Intelsat, which could potentially free up 100 megahertz or more of additional spectrum should they be able to further consolidate and repack. So this is an interesting opportunity. One other data point is that Japan's ministry has already approved the use of spectrum up to 4.1 gigahertz. And UK has also revised some guidance to allow some access to spectrum at medium to low power in the 3.8 to 4.2 gigahertz range. So all these things we're watching as these developments unfold, but the upper C-band is a good opportunity here. One of the second cases that we looked at was the allocation of 6 gigahertz spectrum. Of course, that was for unlicensed use here in the US for standard power applications. So that was the FCC's decision, everyone will recall, to allocate 1,200 megahertz of spectrum, the use of automated frequency coordination systems to coordinate with fixed microwave and broadcast auxiliary has been utilized, and of course extensive interference analysis and predictions were done. So there was good collaboration between the spectrum sharing groups in the WIN forum and leveraging work that was done in CBRS to develop these AFC requirements. And subsequently, the FCC, as everyone knows, has authorized the use of several AFCs. One of the other interesting developments is that both in the UK and other parts of Europe are evaluating sharing between licensed spectrum and Wi-Fi in the upper 6 gigahertz band. They're evaluating two different options. One is the notion of indoor-outdoor, which was mentioned earlier, and also sort of a variable spectrum split. So they're not only analyzing that, but they're also utilizing these UK, what's called spectrum sandboxes, to actually do technical analysis and economic evaluation of how this would work. CEPT is targeting having a report by mid-year next year. So we're looking forward to continuing to monitor the work that both the UK are doing as well as CEPT. It's interesting as a side note that very recently Hong Kong actually auctioned off 300 megahertz of spectrum at 6 gigahertz for IMT for about $81 million US. So their currency is different, but that went to 3 different operators, 100 megahertz each. So we've developed these preliminary recommendations for the FCC to consider as they consider, looking at spectrum bands and how to repurpose. And number one is to look at what was done in the C-band, adopt what worked well, and maybe do things a little bit earlier as using techniques that were utilized in the C-band with multi-stakeholder groups and early evaluation and testing of devices between bands and within bands. Number two is to evaluate this opportunity to free up the upper C-band to at least 4.1 gigahertz and perhaps above. So there's good opportunity to work with the FAA and the aviation community to promote better altimeter and better filter performance. Of course, what goes along with that is to be sure that they do the right job with repacking existing satellite services and both the economic, competitive and technical consideration for the licensing schemes. Number three is continue to evaluate opportunities for spectrum sharing using geographic or database solutions such as AFC where appropriate. And lastly is continue to monitor the progress of both the UK's Ofcom efforts as well as CEPT in Europe for hybrid sharing between Wi-Fi and licensed spectrum, and consider any applications that may apply to the US. So those are our preliminary recommendations, and I'll stand for any questions you have.
Questions or comments from anyone in the room or online? I mean, I'll just say there is a process point from the whole radio altimeter debacle, which is just, which has come up in the course of other bans as well, which is, you know, we have in the law this concept of finality. Like, everyone has to come to the table, put their objections, go through the FCC planning process, the NTIA planning process, the FAA, whoever the affected agencies are. But then there has to be, you know, a decision that people then have, you know, legal recourse, but there has to be a decision with all the facts on the table. And one of the unfortunate parts, I think, of the radio altimeter issue, which is, again, it has happened other times, is then we have a decision and then all of a sudden folks who don't like the decision go to other players who weren't part of the process. We're kind of revisiting things that should have been decided years ago, and then the decisions get made, revisited, and kind of in a panic mode. And I think that's a bad process.
Agreed. We should have better interagency processes and people living with the decisions that are made.
Right.
Agreed. Thank you.
Right. Okay, we have two online. We'll start Rob Aldifer.
Thank you. Yeah, just to expand on Tom's comments around 6 gigahertz and some of the lessons learned there, I think they apply not just in the context of AFC, but also in the low power indoor framework that the FCC landed on for spectrum sharing. And that was done through a pretty in-depth technical process run through the FCC's own engineers and stakeholders providing input to get comfortable that indoor operations would provide enough separation and signal loss to avoid interfering with incumbent systems. And it's a relatively simple, straightforward approach. It's been successful. There haven't been reports of interference to incumbent users in that band, and it's been commercially successful in terms of enabling new uses, since we see actually most use happens indoor. So it's an interesting additional point around spectrum sharing. It doesn't necessarily need to be overly complex in order to be successful.
Thanks, Rob. Henning?
Yeah, so one additional lesson, I think that the altimeter issue is that often when that occurs is that you have these dueling consultancy type of problems where everybody hires their favorite consultant to do often a desk analysis in that. And so one of the lessons in general is to have a established set of reasonably trustworthy and experienced entities, whether that's the FCC labs or some of the NTIA facilities that are available, tabletop mountain type thing, or whether that's a university consortium or some entity where it is at least harder to accuse that entity of being commercially affected by whoever's paying their consulting bill in that. And the second one that I think we should consider broadly was that there was a lot of disagreement as to what the operating parameters were. How far away from the airport are we talking about? What elevations are we talking about? What are the characteristics of the cell towers in terms of antenna angles and so on? So having a better set of agreed upon operating definitions as to what are we caring about? Are we caring about every single airfield, even though commercial airliners may not typically land there? Are we talking about private aviation and other like interference scenarios? I think that would help if to do that early on. So having both labs ready that are equipped to do that, and as well as having kind of an agreement on obligations and maybe a more reasonable expectations as to where do you do the cutoff, as in, is it reasonable to accommodate 50-year-old devices versus 10-year-old devices, recognizing that different fields of incumbent use have different turnover in their equipment in that. But having those established ahead of time avoids these mentioned last minute, or may reduce at least bad faith last minute attempts of overturning previous consensus.
Yes,
Moving
great
the
points, Henning.
goalposts, basically.
I'd agree on both points that it makes sense to use trusted folks for analysis and for testing, third parties, and then as well to make sure we agree on the parameters for evaluation and don't keep moving the goalposts. Thank you.
Yeah, ditto. I agree as well. And of course, that's a big function of our talented, dedicated staff at OET. They deal with these issues every single day, and they have people come in and make technical claims, and they have to discern which of those claims have merit, which might not, and which need further study. And again, that's all should be part of the process before, and is supposed to be part of the process before the FCC adopts a rule in a given band, and should not be something that's brought to the fore way late, years after the fact, and not bringing in other players who weren't at the table when the rules were adopted. That's kind of core to the administrative process, I would say. Anything else for Tom? Okay, so Manish and Andy, back to you guys.
Next presentation will be Jason. He will be presenting combined recommendations for charter items 6 and 8. Jason, over to you.
Good morning, and Chairman Brenner, thank you for the opportunity to present to the OET and to my distinguished colleagues. It's a great room to be in. First off, item number 6.1 and 6.2. We talked a lot about candidate bans and sharing mechanisms that could be used specifically indoors. And when we evaluated the question, the approach that we took was more of I'll call it an aggregated opportunity. Several members of this committee has looked at this conversation before, and we could have just answered the question. What we wanted to attempt to do, though, was take some of the synergies that you guys have identified and apply them appropriately so that there could be both a business and a technical outcome. We do not presume to change policy or recommend any kind of economic situation as our recommendations are technical. But I think that we took a point of view that said taking a step back from how we've approached containment, how we've approached indoor usage and what it's specifically being used for, and what are the use cases that it is being used for, to have a more holistic discussion about how we might approach this question. So part of I won't say we're at consensus yet, but within the working group, we're pretty close. But I feel like that would like to make the recommendation that as a committee, we redefine indoor only to more about containment. Containment being that there are locations in urban areas that's a rather difficult task versus an outdoor strip mine someplace located in a very rural area where containment could also be easy to do. So we took that lens on how we would approach it, and we also took a collective review of the work that this committee and several others have already done to identify what are bans that could be used and sharing mechanisms that could be used. From a sharing mechanism perspective, we also believe that the SAS offers a great opportunity to be leveraged further in a more unified way, which would allow the sharing to be collaborative and also unified. One of the challenges is as we introduce these different bands and technologies, the sharing mechanisms have a tendency to evolve. So by subsidizing that conversation and saying that here is the sharing mechanism and then leveraging the data that's in that sharing mechanism, we believe that there's a good opportunity for leveraging that for a more common approach. We also think that enhanced measurements now that we have a proliferation of fairly cheap sensors in the form of cell phones and software that runs on those, we believe that the aggregated metric use of that telemetry and data that could potentially come from those devices offers a unique opportunity to actually sensorize things that you guys have not necessarily been able to instrument in the past. And we think that based on work that you've already done, this committee's done in specifically the cable industry around containment, there's language and policy that you've already written that could be reviewed and potentially repurposed to apply to some of these next generation sharing mechanisms. We also proposed the bands, not to ignore the homework assignment, we also proposed the bands that we felt would be useful for sharing. And I think it's important to note the specific purpose for the higher gigahertz bands is because containment is, from a physics perspective, easier to provide. So from an indoor usage perspective or a contained spectrum perspective, many of these bands will have containment policies that are easy to enforce. We recognize that there are probably some other bands that will be actually more useful in dirty environments that have things like metal flake or in industrial settings. But those have already been argued several times before the committee, and we just assume that those bands have their place and there's policy set around them. From a recommendation perspective, I'd say that this is near consensus. We still need to go through the vote of the working group and then to the full body of the committee. But there is a formal white paper that coalesces all the thoughts that are being presented here in our preliminary recommendations. So the first one is to adopt a containment-centric spectrum management approach. We recommend that going forward, as candidate bands are identified for specific use cases, we recommend that those be defined as contained so that those things can be easily deconflicted and allow for the, let's say, expanded use of that spectrum without having to spend a lot of time in deconfliction, especially with the bands that are being recommended, because you probably won't have as many deconfliction points that you'd have to deal with. Second, setting measurable standards for that, because sensors, phones, are widely available. Being able to identify bleed, identify signal and strength, we should be able to easily regulate or potentially regulate that type of an environment. Third, from a industry collaboration perspective, and I think this is one of the key points, being able to query data that's in a shared repository for the purposes of research and improvement and expanding upon automation of band selection and the removal of having to have large number of subject matter experts always tuning and fine-tuning the systems is going to be really important. Since you have a shared database, being able to put some of those metrics in that database that could help in the automated selection of bands that are being used in specific areas. We think that's possible. And then last but not least, leveraging a technology like dynamic spectrum access. When you think about the challenges that we have with the finite number of resources around spectrum, having those registered is one thing, but measuring their use and their efficacy is possible, but not currently being done. I think it's in the roadmaps for the things that you guys are looking at, but we think that that could be accelerated and potentially be used to both provision wisely the resources, but also have some quality measures of how that spectrum is actually being used, and then automate the function of that. Any questions?
Questions or comments for Jason? Thanks very much. Another very clear presentation. Bill.
I just wanted to applaud the presentation and say thank you. It's something that Cisco is dealing with this issue in the 6 gigahertz band quite frequently. The concept of containment is really, I think, welcome from our standpoint. One of the things that we've run into with the 6 gigahertz band is that customers purchase Wi-Fi equipment and they don't understand that they can't use that equipment the way they've always used it. And it especially doesn't make sense to them when you tell them, well, this can only be indoor only. And they say, well, I'm a mining operation hundreds of miles from any potential fixed links. I don't understand why I can't do this. Another example is in sporting stadiums where the line between indoor and outdoor is a little vague. And so we sometimes have to explain, well, this concourse is open to, it may be indoor, but it's theoretically open to the air because at the end there's a tunnel that opens to the stadium. So this concept of containment is really interesting, and I'd welcome the opportunity to explore it more.
Hey, thanks a lot, Bill. Other comments or questions? Oh, Henning again. Thanks, Henning.
Yep, I just to emphasize that I think one area that we'll increasingly see where the consumer does this thing have an IP66 enclosure or doesn't it just doesn't work is in embedded systems such as in vehicles and aircraft and so on, which are probably as well shielded as most other indoor locations, but just don't fit the model because the transmitter is often encased in the vehicle structure and so on. So there are lots of applications where some of the 6 gigahertz and other bands would be quite useful, but just we don't want, as it has happened recently with sports stadiums, an example, where every such application has to get a specific waiver request from the deployer to the FCC, because I suspect the FCC staff has better things to do than do test drive cars and decide whether that's actually something that has an open or retractable roof versus is a traditional hard roof type of vehicle or whatever else might determine that.
Thanks. And again, Bill, thanks. Those were great practical questions that wouldn't necessarily be front of mind in fashioning a FCC rule. So, Jason, thanks a lot. Andy and Monisha?
Yep. Thanks, Dean. And we just have one left here. Hold on one second. Got it. Okay. Very good. We're good. So, Rob, it's over to you, and I'll change the slides for you.
Great. Thanks so much. So I'll be covering Charter Item 9, which covers efficiency, energy efficiency, and sustainability. And just as a reminder for the question the FCC asked is around trade-offs between efficient spectrum use and environmental considerations, including sustainability and energy efficiency. And Dean, in one of the last meetings, you encouraged us to look through the lens of not just trade-offs, but also synergies between spectrum sharing and energy efficiency. And so the status of this work is that we've done some initial fact-finding. We have some interesting observations to share today that do, in fact, point towards spectrum sharing supporting efficiency. And we'll continue to learn more as we develop recommendations into next year. And so where we started to kick off this work, we heard from a set of researchers at UCSD that have been looking intensively at this topic, modeling network architectures and looking at energy implications. And the key finding really is that greater network density, which is efficient in terms of spectrum reuse, also leads to greater energy efficiency. And essentially that conclusion was reached by modeling through a pretty detailed simulation a mobile network architecture and finding that moving network nodes closer to end users increases energy efficiency even when you have more nodes. And that's really a function of two primary factors. One is A reduction in distance means lower propagation loss, and that's energy lost as well as signal. And secondly, a reduction in clutter means lower non-line of sight losses. So eliminating obstacles for wireless signals through trees, buildings, walls, etc. That also reduces power needs. So UCSD characterized the potential for in the neighborhood of 3 times energy efficiency gains in small cell versus macro mobile networks. Again, based on a pretty detailed simulation and optimizing small cell placement to drive greater energy efficiency without sacrificing performance. So that was their key insight, and it applies really to both mobile networks as well as to Wi-Fi. As we heard from Dinesh Baradia at UCSD, those non-line of sight and distance-based signal losses can be reduced along with the energy needs by serving local traffic with local networks. So what we want to do is validate these findings and expand on them as we develop recommendations to the Commission. Let's go to the next slide. So we do have some initial extrapolation of those findings to share, starting with some key trends around small cell deployment. Most folks are probably aware small cell deployment continues to expand along with shared spectrum deployments. The chart on the page here is a general forecast of small cells by Kagan Industry Observer. We'd note that NTIA has also recently noted there are over 400,000 CBRS nodes deployed. That's up by nearly 100,000 in the last year. So those are all generally lower power networks using spectrum shared with federal incumbents. And that highlights another point of synergy between spectrum sharing and energy efficiency. The sharing frameworks we develop may consider lower power commercial transmissions to operate effectively around incumbent users, and that approach can not only open up more spectrum, but it can also yield greater energy efficiency in the process as that spectrum is put to use in the commercial context. Let's go to the next slide. Another important point to note is that not only are small cell networks growing, but user trends also suggest some opportunities for continued growth in energy efficiency in terms of wireless delivery. Users spend typically, as I mentioned a bit earlier, around the vast majority of their time indoors. Nokia and OpenSignal and others have characterized that as around 90% of the time and the data associated from mobile devices is actually served indoors. That generally happens over indoor Wi-Fi networks, and we see this across carriers today, taking advantage of local Wi-Fi networks to serve mobile traffic. That, of course, those mobile devices also have access to macro mobile networks, but they use Wi-Fi in this context and that's energy efficient for reasons we've already described: less distance, less non-line of sight losses. And in addition, we just would observe Wi-Fi networks themselves are growing incrementally more efficient through new developments, new standards, including things like targeted wake time. So this trend of serving traffic closer to users is also important in the mobile context and is one driver for the growth of small cells that we've also observed. Let's go to the next page. To reinforce the indoor and Wi-Fi usage trends, it's also helpful to dig a bit deeper and look at network traffic to understand why those trends are happening. Video, of course, continues to be the dominant application class in both fixed and mobile networks. The data here is from Sandvine. And consuming video is inherently a stationary activity, so it makes sense that we see this data-intensive application class manifest in indoor environments, homes and offices. So we see this, corroborating the heavier data load on fixed networks versus mobile by looking at application usage patterns, and all of this really, for us, reinforces the opportunity to continue to drive greater efficiency in wireless delivery by emphasizing the use of local networks to serve local traffic. Let's go to the next page and talk a bit more about mobile network architectures and energy efficiency. There are some developments in mobile networks themselves that will yield the potential for greater energy efficiency. And as a starting point, we would expect to see network energy use increase as we add spectrum bands and larger antenna arrays, all things equal. But through shared spectrum infrastructure, network optimization, you can start to mitigate this effect. So the image here is an Ericsson architecture showing a reduction in the number of radios through modernizing from a 2G, 3G, 4G architecture to a 4G, 5G implementation. As you do that, you can layer in new frequency bands, add capacity, simplify the network a bit, and that has the effect of reducing energy consumption, giving you effectively greater capacity at incrementally less energy use. And there are other mobile networking developments that we have on our agenda to explore in more depth in terms of their energy use implications, infrastructure sharing, RAN sharing, and multi-operator core networking, as well as Open RAN applications, all have the potential to grow energy efficiency in mobile networks. Let's go to the next page. So that trend that I was just observing, getting more bang for the buck in terms of energy use for data delivered and capacity, that's also happening in the Wi-Fi context as well. As speeds have increased over time, we've seen energy use remain roughly constant from an access point energy consumption perspective. The data here is an industry level view across a range of routers and vendors used in both retail and service provider Wi-Fi. And this comes from an industry consortium that, for full disclosure, I chair, that is committed to continuing to grow energy efficiency gains in Wi-Fi and other consumer equipment. So that's another good trend to point out. Let's go to the next page and talk about next steps. I'd say there are a number of positive trends we can identify from a sustainability perspective: energy efficiency of small cell architectures and shared spectrum concepts, market trends that are driving network densification and movement of network nodes closer to users, including serving indoor traffic from indoor networks. But we definitely have more to learn as we form recommendations. As I was mentioning, the implications of new technologies, including AI, as well as Open RAN and other shared spectrum network architectures. And in addition, we want to continue to validate the real world energy utilization from traditional mobile as well as new shared network architectures, and characterize the energy implications of spectrum sharing infrastructure itself as you think about operating a SAS or an AFC that will consume some energy itself. And so putting that into context is on our to-do list. So we'll continue to learn more, and we look forward to developing recommendations in this area next year. I'll leave it there.
Thanks so much, Rob. Comments, questions, anyone online or in the room? Marvin?
Does the increasing virtualization of the RAN use more energy or less energy than traditional architectures?
That's a great question. Yeah. I don't have data on that, so I'm not going to speculate an answer. But I think what it does do is it moves energy use out into the network to a greater extent. You probably have some savings in the core, more energy consumption at the edge. How that nets out, I'm not certain.
Other comments or questions? I'll just say, Rob, thanks so much for the follow-up. I view this work as extraordinarily important and exactly what the TAC should be doing. You know, the FCC doesn't have a Bureau of Energy Efficiency. Typically, that isn't really a concept that the FCC has taken much into consideration as it fashions its rules. 3GPP, the IEEE, other standards groups similarly really have not made this a major focus. I think it's starting to come into play in various standards groups, but I think that the research that you highlighted from UCSD is fantastic and fascinating, and I really think this should be something that the TAC very much continues to bring into the FCC. It's something the FCC is not getting really from other sources. Amit?
Just wanted to make a comment that it is easy to get dragged into the discussion that most of the data traffic is indoor, so we need more resources towards Wi-Fi or small cell. But let us not forget that when we do that, we are actually need to have a fixed broadband transport infrastructure built into that. So to me, the comparison is between fixed broadband versus mobile broadband. It is not where the data is consumed. So let us just also keep that in mind. You need to have that infrastructure to make the comparison somewhat equitable. Thanks.
Yeah, totally agree with that. There's no free lunch here, right? Lisa?
Yeah, just more of an observation. You talked about the video traffic and 7 times more being fixed. As we're getting more and more AI enablement, and we'll start using AI with cameras and optimization there, we might want to also prepare for more mobile video as things change. I don't really have necessarily a hard prediction on what will happen, but I do see some things in the future that will start to change traffic patterns in ways we may not expect.
Yep, thanks for that input. Peter?
Actually, that was the same point I wanted to mention, that we expect with mobile AI to be people doing real-time video upload to the cloud to do on real-time analytics and see much more TX MIMO. I also want to congratulate you. Clearly energy efficiency is a key part of the work we're doing, and I second your comment that this is a very appropriate task for the TAC.
Thanks. Monisha?
Yeah, thanks. So I think Rob did an excellent job of presenting the power efficiencies, the power consumptions in the base station. We shouldn't also overlook, especially as uplink traffic is going to increase, and I fully expect that'll happen as well, is how much power your phone consumes. And we've done some work recently on uplink power consumption from your phone, and the reduction of that transmit power is pretty large if you're using, say, a neutral host model rather than an outdoor base station model. So the energy efficiency will include both aspects.
Thanks, and I completely agree. The power that the device uses is crucial here. Bill?
Thanks, Dean. One thing I wanted to mention that we're seeing in Europe is that as more buildings become LEED certified and become more environmentally efficient, that requires macro cell towers to operate at higher powers to be able to penetrate through those windows, through those walls. So that's something that I didn't hear that in the presentation, but I think that's a trend that needs to be kept in mind when we're talking about energy efficiency of networks.
Thanks. Mark?
Okay. Yeah, one of the things that we should look at is that the protocol that we use to transport the data across the network too as well. So currently we're using a mix of IPv6 and IPv4. As the federal government's moving to IPv6 as into May 2025 through the OMB mandate, we should look at that, because in some of the studies by using IPv6 protocol without using IPv4, it cuts down the power consumption by up to 40% on mobile networks. So that's a huge expansion, and it also puts us in compliance with the federal government as it moves through its OMB.
Thanks, Mark. Madeline?
Thank you very much, Dean. I'm curious if the group has looked at one-to-many data delivery services as possible energy savings opportunities. I think there are some studies that have been done in Europe, for example, by the BBC, that studied if we send such and such of content over a unicast network versus over a broadcast network or one-to-many network. It depends on how many receiver devices are getting the same data, of course, but there are cutoffs where the number of receiver devices getting the same data exceeds the amount of energy that it would take for a unicast network to send those devices each their own data packet. I know there's work going on, for example, in the organization I work with, ATSC, about core networks where data can be transferred from a unicast network to a broadcast network and back. So I was wondering if the group has done any studies on, or consumed any studies, for example, on the efficiencies of one-to-many data delivery for use cases where the number of receivers getting the same data is high. Thank you.
I think about that when I'm watching ESPN on my phone. Um, Rob, do you have any comment on that?
Yeah, I could just respond to that one briefly. I would say short answer is no. I've been taking notes on all this great input. Please send me any studies or data you'd like us to consider further. Madeline, on your point on unicast versus broadcast, I think it gets to an interesting set of considerations around how to characterize energy efficiency in communications networks. There's one framework for doing that is energy per consumed byte or bit, so energy per unit of data, and that's one lens. I think it would be interesting to compare unicast versus broadcast in that context and look at, especially for high viewership or high demand concurrent events, which is more energy efficient. My going in hypothesis would be that in certain circumstances, you could have a case for efficiency in that very high demand, everyone watching something at the same time context. In other contexts where individuals are consuming content mostly on demand, you might not see the same level of benefit.
Okay, thanks. Henning.
Yeah, so one remark I wanted to emphasize that we just don't understand, I think, well enough is the incremental versus baseline idle power. And this is becoming, I think, particularly important as many larger homes acquire mesh networks inside the home to cover all their rooms or floors. In that, my suspicion, and I don't know how much good data exists there, that a large fraction is simply the device sitting there doing essentially nothing. There's no incremental use of power based on transmission because it's the base power dominates in that. And that's something that I think consumers and bodies that stand as energy efficiency have not done a good job of necessarily encouraging better standby power use, even though 802.11 and other devices now enable much more efficient turn down of energy use during low or no usage periods.
Thanks. I'll make one last comment, which is this is also an area where state energy regulators have come into play, and Brian is nodding, they have come into play in imposing certain requirements on the energy efficiency of certain consumer devices, and that has really kind of stayed within that realm. It hasn't, that issue hasn't really morphed into the greater need for energy efficiency that we're talking about here. And it's kind of in my view, historically, it's been kind of a one-off, similar to the way some states like California have been leading the way on air pollution regulation, kind of ahead of EPA. But again, I just want to thank Rickon, sorry.
No, finish your thought and then I'll.
Oh, okay.
Jump in, yeah.
So I just wanted to put that out there, but I think, again, this is a fantastic issue for the TAC to take on because it's all input that the FCC is not getting anywhere else.
Yeah, no, thanks, Dean, and totally agree. Appreciate Andy for flagging that. I think just want to add to that, and Rob did a fantastic job in putting this together, and the SME was awesome as well. I think the key thing for this particular charter item is not so much of indoor versus outdoor, it's more of densification and antennas being closer to the users, whether it's Wi-Fi or small cells. So that piece I think we need to keep in mind. So I was not able to actually connect what Amit mentioned, particularly with respect to fixed wireless and trying to tie that with this charter, or was it maybe a generic comment? But this is not so much of indoor versus outdoor, but it's more of a densification and the architecture, small cell architecture, that is actually allowing us to do that. So just wanted to share that. Thanks.
Thanks. And right, that's our way into this whole important topic, but it's nicely been dealt with in Rob's presentation, and I really appreciate it. I'm blanking. Adam.
Yeah, just a quick one. When you start looking at energy use, it's much more complex than just what happens in the communication system, because the consumption in the data centers, the computing, the data storage, the retrieval actually swamps the use in communications. So while it's important here, it's actually important to understand the traffic flows and patterns, okay? And there are several, I would say, nascent models for that. We've had a subject matter expert from CMU, I think Satya, who actually did a measurement. And quite often what happens is you try making the communications more efficient, okay? But the way you use the network actually consumes a lot more energy, okay? So there is something that's just, how would I put it, outside the bounds of the FCC that greatly affects the equation here.
Great cautionary input. Anyone else on this energy efficiency topic? Okay, and Andy and Monisha, do you have anything else?
No, I think that's the end of our working group. Thanks to all the members. I think this was a very, very efficient session that we had the last 9 months.
Well done. Thanks so much to both of you. So we will now move to AI and ML. So Adam and Lisa, take it away.
Great, thank you so much. I think I need a clicker. Thanks, Andy. All right, so we'll get our slides going. Great, thank you. So this is the AI working group. We don't plan to come with specific recommendations today, but we are continuing our journey toward them and have some future action plans we'll be going over. We'll also be covering a little bit of where we think we're going to be heading for recommendations. So you'll get a little bit of a sneak peek at what we're doing. So the outline for today is we'll talk about the membership quickly. I'd like to review our charter just so we're all on the same page, as always. Item 3, I want to spend a moment talking about how critical the FCC's role is as the AI becomes more and more involved in networking and the ICT world in general. We'll spend most of our time today, item 4, on a summary of progress on the AI working group charter items. Adam and the rest of the team will be covering that, and then we'll go through priorities and a white paper outline for 2025. I also want to point out we have extensive appendices that are available when this presentation gets posted online, also including the several speakers that we had over a variety of topics. We have so much material to cover, I'm not going to include it here, but there's a lot of deep material in the appendices I would encourage people to look at. So quickly to go through, we have members from across the industry, vendors, operators, academia. We have our FCC liaisons. Very, very grateful to all the work that's been going on so far with this AI working group topic, which I think incidentally we've been working at probably since 2017, I think. That's right, Adam. So a lot of work as this is evolving. And let's jump into the charter. So we have 4 buckets for the charter, and they're split out. I'm not going to read this whole slide. We'll flip through this. But we have AI and ML for spectrum sharing and management. Oh, thank you. Thank you. There we go. Thanks. I'm going to try not to forget that again. Bucket 2 covers network safety, security, assurance, and performance. Bucket 3 is testing regimes for AI, ML in telecommunications. And bucket 4 is the softwarization of telecommunications. And the way we're covering this is we've broken into, we have the main group, and that's covering bucket 1 and 2. And then we also have a great sub-working group, which is bucket 3, bucket 4, the softwarization sub-working group. And you'll be hearing quite a bit of output from that group today as well. So let's switch gears a little bit, talk about the FCC's critical role as AI evolves and the future of ICT in general. So just a few general points here. We all know rapid technical progress in AI, ML. There's a lot of hype, but there's actually a lot of real things, and there's a lot of things that need to be fixed. and they will be coming rapidly. In fact, I think we all in this room could say we're somewhat surprised, I know I am, in how quickly AI is becoming more and more prevalent in all of our lives in so many ways. And it is especially becoming important in telecommunications. We always, in this AI working group, because AI is such a broad topic and it covers so many things, we always try to go back and anchor ourselves in the FCC's strategic goals and from the FCC strategic plan. So just to remind us, the work we do is anchored in things that will help the strategic plan, such as broadband availability, leadership, competitiveness, national security, and operational excellence. So to the point of AI and the evolution, there are many models about the roadmap to AI and how do we get there. And right now what I'm specifically talking about is AI as it applies to networking. And I'm using networking in a broad way, telecommunications, and other things that use networks in the world. So I'd say if you look at this drawing, we've got about 4 steps here: manual configuration, applied intelligence, explainable networking, and full cognitive self-learning. I'd say in the world, or our group, the AI working group, assesses that we are somewhere beyond manual and in the beginning of the applied intelligence. We will be heading toward cognitive self-learning, and part of our charter was, for this AI journey, was where and when should AI ML be used and where can it be trusted? So this is a very important question. There's a lot of writing about it. I think we took this as one of the most important ones, as maybe you can build it, but what should you build? And this gets to the point that cements what I'm talking about in this section, which is a very strong governance model is needed, and define core principles and put them into practice. And that's where we see this FCC's critical role. So what I'm hinting at here is I expect we'll have some recommendations starting to formulate throughout the year, ready to present by August, talking more about the critical role and how it can be used in this context. We've got a lot of transition going on. I don't have to tell everyone in this room the transition that we're going through: 4G, 6G, devices everywhere, AI native being the ultimate goal. The industry is happening now. There's already $200 billion in AI being spent now, growing 37% annually, and in 2030 it's projected to be in the trillions. What I noted, and this is kind of why I made the comment earlier, if you look at it, and I know this is hard to read, so I'm just going to call out a couple of interesting points. The global AI adoption rate is highest when you get to things, this top one is robotic process automation. So think about things like car manufacturers or chemical plants or warehouses. All these things require a network. They will require, and these things are largely in motion, so they will require something wireless. So it will be very dependent on spectrum. I find our topic quite tied to the spectrum sharings topics, and we eagerly watch what they're doing. But that's important. The second one on here is computer vision. And AI is increasingly being adopted with computer vision, which is increasingly becoming wireless. And then, of course, the usual suspects, down the list is digital twins, and even language, speech, and even physical robotics. We all found it a good data point to share of the impact of AI on industry growth. So now let's look at what happens. The top category there, again, it's a bit hard to read for all of you, but it's information and communications. And it is the top impact out of all the industries you can have: manufacturing, financial, healthcare, agriculture. The very top one is information and communications. And we see generative AI market growth at 42%, meaning that's really where you'll see a lot of AI growth going forward. So again, to really bring home the point, the FCC will have an important role to play because things will need to connect. They will need to use the network. The industry is spending money on it now. It is the top industry that AI is impacting now, and generative AI is outpacing general AI growth. So with that, I think I'll turn this over to you, Adam, to talk about some specific progress on our charter items.
Okay. So I think as Lisa...
I see Ian has a question or comment. You want to...
Go ahead.
Something to interject?
Absolutely.
Or is it because those telecom networks are going to use more AI to be more, I think it is the adoption or is it the driving?
I'll start.
Go ahead.
So I think it's a little bit of both. So the foundation of AI is going to be largely networking. But what we've seen, if you look into the data thus to date, there's been incredible investment in traffic prediction, the ability to interact with the telecom industry, interacting with customers using AI, preventive maintenance, lifecycle management. So it's been, so the part of your question, there is a substantial pieces of that are the industry investing in itself and reliability of the networks. But what we expect to see take off more is AI needing networks more and more.
Thanks. Okay, Adam, move to your next stage.
Okay, so I think as Lisa introduced, we have 4 buckets to talk about. The first one overlaps a little bit with the spectrum sharing group, but I would say what we have really done is taken a look at the long-term impacts of AI and ML, not what's going to happen in the next 2, 3, 4, 5 years, but really what are the goals long-term, going towards a regime that is fully automated, dynamic, and gives you efficient spectrum sharing. Not that we have all the answers on that. Bucket 2 is really the performance of the network as it goes towards an AI ML native world. Bucket 3, which I would say we can't understate, it was probably the shortest item in our charter, but I would say testing probably ends up being one of the most important items. So we'll be talking about that. And the last is the softwarization trends, to which AI ML adds a great deal of complexity to something that's already complex to begin with. Okay? And so, let's see, am I going the wrong way? Okay. It's hard to do those. Okay. So the first of those is AI and ML for spectrum sharing. Again, we have had a number of subject matter experts talk to us, both from academia and from industry. It's a very complex problem. I think the FCC, a lot of the vendors, the users have been at this for a long time. But, you know, just looking at it sort of top level, it's really balancing the requirements and avoiding harmful interference at the same time. It's protecting the parties who have to be protected, giving them preemption, things of that sort. And I think, as mentioned earlier, I think by Amit, the economic and operational viability of the solutions, including transition costs. I would say the problem is very highly complex. The whole issue of propagation, I think, as people have already mentioned, you know, you have indoors, you have outdoors, you have a tremendous amount of difference in settings in which you are trying to do that. What you find is you know, that if you were to look at the maturity of the AI technologies at this point, they're still not quite there for the problem of the scope. Okay? And by that I mean the following, to give you an illustration. there are lots of uses of AI and ML. We're getting you a 90% answer is good enough, okay? And if you're doing a search or something of that sort, that's more than good enough. If you go to talk to an expert, they won't even give you something at that level, okay? If you try to use generative AI to actually create some text, things of that sort, without having an intuition, again, you'll get some funny things that end up in there, okay? Again, even with the best of it, okay, you tend to get to that 95, 96% level, okay? Hard to get beyond that. To extrapolate it to have the kind of performance you need in the network without fallout, okay, where you might need in the least 3 or 4 nines in things, okay, it's very, very hard to get to solutions that you trust without finding some kind of decomposition for the problem, breaking into smaller pieces, each of which has the required accuracy that you need, okay? And that is something that'll take time. The overall problem, I would say brute force is not tractable at this point in time. And we have a fairly comprehensive appendix on, I would say, this set of issues. Let's see, 4.2, I'm still on 4.1. Okay. If we look at it, I would say from the discussions, it's the ability to understand real-time spectrum. Sorry, I think I'm still on the wrong. 4.2. Let's see. Okay. Sorry about this. Okay. There we go. Okay. Yeah, why don't you click for me? Okay. So I would say the next one is, I think in our charter was better understanding of real-time spectrum usage. That I would say is actually a different situation from the overall sharing. I think that technology is already here. We had a number of great talks. I think Tim O'Shea gave one of them. But what it depends on is really availability of data, having the right kind of sensor networks, things of that sort, whether it's data from end users, deployment of sensor networks, operator data from base station equipment, and data fusion from Earth and space-based assets, things along those lines. And I think as Tim showed in some of his presentations, you could actually tell what was in the spectrum, what protocols were being used, whether there were things out of whack in that spectrum. So a considerable number of examples. I think this kind of technology is here and ready, essentially. If we could go on to the next one, which is dealing with network safety, assurance, and performance. So I think if we look at it, at this set of issues, and I think, again, it's in one of the slides that Lisa showed earlier, AI and ML and its use in various parts of the network over the life cycle of the components that go into the network really will have a profound impact on its architecture, the way it is run, and degree of actually automation. I think to make progress towards that, it's sort of important to have a framework in which AI and ML is used within the telecommunications industry. We have some of that addressed in section 4.3 in terms of the testing that needs to be done. Essentially, we can go on to the next one. Okay. I would say that, excuse me,
There is an incredible amount of promise, an incredible amount of work going on, how to incorporate AI in various things. All the way, I would say, from the design of the components that go into the network, things like filters, amplifiers, the processing systems. We see actually a tremendous amount of activity in that area. And if I look at all of the major vendors, all of the major chip makers, I'd say they're all starting to, in fact, embrace the AI, ML technologies in their areas. If we could go to 4.2.2, this was to explore AI-enabled networks and some of the issues of complexity. And I think it's important to say two things. AI, in fact, is a great tool of dealing with some of that complexity. And adopting it, I would say, makes a lot of sense. But there's a time scale in which all of that technology becomes mature. Okay? So having roadmaps, things of that sort, makes a great deal of difference, essentially. And it's also important to figure out how do you use AI, ML with other techniques at the same time, and sort of have a systematic, I would say, disciplined way of understanding when the technology actually reaches a threshold where it can be safe for use. Okay? So this is, again, sort of the maturity issue. If we could go on to the next view graph. Okay. The next thing on our charter was how can AI ML techniques be used to address the challenge of data quality? And to that, we have four sort of top-level answers. The first one is actually cleaning the data that we have. Okay? Anomaly detection, prediction of filling things that are missing, the use of natural language processing, and adaptive rules through reinforcement learning. Data fusion, the ability to grab things from different networks, using a very different aspect of AI, which is graph neural networks, so you have some causality in the answers that you get. If we can go on to the next one. The ability to actually use AI itself for anonymizing data. And then lastly, for data protection itself. But I would say in conjunction with other cryptological data sharing methods, such as multi-party computing or full homomorphic encryption or differential privacy, essentially. Okay? So a lot going on in this space. If we can go on to the next one, which is 4.3.1. So this gets to the testing regimes for AI and ML. What I'd like to do is recognize Balaji Raghunathan from Keysight, who actually put a lot of this material together. And if you look at it, there are really sort of two aspects to it. The first one is the testing of AI and ML for use in telecommunication networks themselves. I think I'm not going to go through and read everything on the view graph. There's a short list that's here. If we can go on to the next one, please. Okay. What is important to recognize is there are already quite a few frameworks that have been established in this space for AI ML certification in various other industry sectors and other geographies. And they provide a good baseline for current practice, for compliance. They're all undergoing, I would say, rapid evolution, so one has to watch that. Some of the ones that are in place at this point are the NIST AI framework. ISO has one, IEEE has one, and there is a major amount of work that's been done by ETSI in the EU at this point. I would say besides these frameworks,
You find the systems engineering folks, Incazi, outfits like that are doing something very similar, and the same thing for CMMI at Carnegie Mellon. Okay. So if we can go on to the next view. I think I'll probably skip this one. Let's go on to the next one. Okay. I think, again, on testing of AI and ML in telecommunication networks, it's aspects of the telecom infrastructure that are actually impacted. So it's the control systems that work on very fast timescales, things that massage the payloads, the management plane on a much slower timescale. But in some sense, the whole network life cycle from planning, development, deployment, operation, maintenance, upgrades, AI has a role in all of those. The test methodologies have to be actually created for the various stages of the AI ML cycle itself. It's very important to have data sets, ability to actually trade them and share the data. The models themselves have to be tested before and during deployment, and continuous evaluation and tuning of the models in operation itself. So there is operational testing that goes on live, okay? And there are common threads of testing, but also domains and use case dependencies that are very important. So again, a fairly complex set of issues. Let's go on to the next one. Okay. And if we were to take a look at testing of AI and ML used in telecommunication networks, I think one of the preliminary recommendation areas is to actually sort of worry about forming the right bodies for doing it, making sure within the FCC itself that you have the right resources, the tools, things of that sort to do this. And this becomes increasingly important for almost everything in the network. And when I say AI and ML, it's actually worthwhile to throw in that the accompanying software that goes with it that may not be AI and ML based also deserves the same degree of scrutiny as everything else, in particular because of softwarization. Let's go on to the next one. Okay, the next is, I would say, AI and ML for network testing. Again, sort of a very, very different aspect of things. If I were to take a look at 5G, which we have right now, I think what we got from one of our subject matter experts is if you look at the number of parameter settings in 5G, it's north of 6,000, somewhere around 7,000 parameters, likely to grow for many reasons, okay? And again, being able to test everything from the component level, subsystem, systems level, and the network level involves a great deal of complexity. I think AI, ML may be fairly good at discovering some of the patterns, getting you the statistical coverage that you need. So everything from test generation, faster testing times essentially, figuring out how to do this scalably so you can actually have that good coverage and do it cost effectively. And then lastly, sort of anomaly detection during deployment and operations. Okay? So again, very important. Can we go on to the next one, please? Okay. And it is worthwhile to actually take a look at what goes on in other sectors, in the automotive industry, in manufacturing and robotics, healthcare, financial services. And those are fairly important because they've developed platforms, human lives are at stake. I think there's a lot of rigor that has happened, and
I think for the FCC and for our community as a whole, I think there are lots of lessons to be learned from other sectors, essentially. Let's go on to the next one. So I think if we were to look at it, preliminary recommendation areas, is to say that the increase of software-driven functionality for control, management, conduct of operation has a profound impact on the reliability, availability, and performance of the network. Inclusion of AI and ML in network functions only exacerbates the impacts. The other is the impact and crucial role that computing, data storage facilities now represent a large fraction of what we call the network. Okay, I can tell you that having spent quite a bit of time with the AI community that's trying to deploy services, the reliability of the hyperscaler plants, things of that sort, isn't quite what they expected it to be. So they're battling with making sure, okay, that the facilities that are being put together for the AI models, sources of data, the things that build the LLMs, things of that sort, actually come up to the right level. They're not quite there at this point, okay? Okay, and so understanding that and having an AI ML-based testing framework, adoption of best practices and things of that sort becomes an area that the FCC should actually prepare itself for, okay? So I think with that, let me turn it over to Ardavan, who's going to go and 4.4.1. Yes, it is. Okay. What are the opportunities for the Commission to use AI/ML to improve the analysis of data? Again, a lot of things. And the first starts off with the fact that the FCC is an important source of data for the industry as a whole, both for commercial and individual consumers, and for verticals that rely on telecommunications infrastructure and services. And the FCC also relies on data for its internal processes, okay? So using AI and ML to assure the quality and accuracy of what is contained in the databases is fairly important. We have a very good example of that. If you look at Appendix A6, that was put together by Sachin Gupta and Lynn Merrill, and it looked at the quality of the maps used for rural broadband and things of that sort. Very good write-up on what ought to be done there. The next is really classification and characterization of the information within the FCC databases. I would call this sort of discovery, the use of AI and ML to sort of show us the patterns of what's there. The next one is sort of the much more common situation, okay, and that is the FCC actually faces a problem. It wants to figure out a way of solving it, build models to do that, okay? And there, I would say generative AI becomes an important element. And then lastly, I would say, in the practice of AI and ML, it's really to build up a high-quality query layer for general AI and ML applications, the ability to share data. And what we come back again to is, I would say, the existence of large language models, and specifically one for telecoms, which actually is one of our preliminary recommendation areas. Martin, if it's possible, could we jump to slide 79?
While that's happening, Adam, I wanted to interject one comment on one of the issues you already discussed, quick one, which is just, you know, as usual, there is just so much information in your slides and in your presentation. And there's a lot to digest, but I wanted to highlight just you had some information about the use of AI by the auto industry, and I think also, which you mentioned, and also I think in the slide it said the pharmaceutical industry.
Healthcare.
Yeah.
Financial services, all of those, yeah.
Right, in the use of AI and ML in testing, right? And I just thought that that's, really great information to have for the FCC to have. Again, the FCC doesn't have an AI ML bureau. This is great, a great input. And again, one of the important functions of the TAC is a information gathering, information funneling role. And I think that's, again, the FCC has no way of knowing what is the financial services industry, how are they using ML. So that was great input. Yeah. Thanks.
Let me actually say, I mean, this is, since you mentioned that, let's say I look at the financial industry. Within that you have outfits like Vanguard, Fidelity, okay, that hold, each of them holds, I'd say, retirement stakes for 40 or 50 million Americans. They go through extreme steps to actually test everything. Because what they've learned is a single misstep causes a firestorm, okay, on their infrastructure. Okay? And they worry about the interfaces, they test those, the content, okay? And it's worthwhile understanding how well it can be done if it's done in a very disciplined way. Okay, so just a quick question on the slide numbers. When merging, we've created global slide numbers, not local ones. So is it Appendix A3? Yes. Okay, we're there. Okay. Okay, so
Thank you.
I could quickly go, I'm going to go to Appendix A3. Okay, this was actually, the appendix is creating an LLM for telecommunications. It was put together by Tian Lan, okay, who sits on the Softwarization working group. And if we could go to the next slide, please. Okay. So if you take a look at it, large language models are AI systems designed to understand and generate human-like text based on vast amounts of data. They're not just text. It can actually be multimodal. It can be everything from I would say, images, sound, and it turns out you can actually perform engineering functions with them, okay? So they're fairly important. If you look at it, they're actually fairly large, expensive to run, growing like crazy. To give you a statistic, in 2017, one of the first models, there were two of them built. One was the GPT folks, and it took 10 to the 23 flops, okay, to actually train that model. The amount of time was over a year, essentially, okay? By 24, I think this year, somewhere around 150 models out there. The latest one, over 100,000 processor units, okay? Again, takes something roughly a year to train, okay? So still a limited number at that kind of class, essentially, okay? If you take a look at it in terms of performance and you use human being responses to similar things as a benchmark, there really quite a few of them are starting to approach expert human level performance in terms of being able to parse data and get something out of it. I'm not going to go through the size of things, but that's growing like crazy. There's a reference there, okay? But let me actually say that there is something very important that has happened, and that's the rise of domain-specific large language models. Probably there are two of them that have been
widely publicized. There's one called alpha geometry, and there's one called AlphaFold. And what you find is when you look within a large language model, specific domains tend to have isolated areas that they occupy within that large language model. Tuning those up seems to improve results significantly, okay? Which is why it's important for this industry to actually create one that's available for telecoms, okay? And what they give you is specificity. They capture contextual nuances. They capture concepts in much more depth. And they can specialize in terms of the kind of inference that you get out of them, okay? And so what you find is, as shown in the picture on the right, you take a generic LLM in which there's a lot of dirty data, okay? Because labeling data, cleaning it up is extremely expensive. That is merged with domain-specific corpora, okay? And it creates a domain-specific large language model where the use of language actually comes from that generic LLM, but what it's allowed to produce in the answers only comes from the domain-specific data. Okay. There are a few terms out there for this. One of them is called RAGs. Those are called retrieval augmented generation, okay, where the RAG itself contains the specific data, okay, that's already vetted, cleaned, and you get rid of things like hallucinations, funny answers, stuff of that sort. It is an activity that has to be probably done by the community itself. You know, data sharing, things of that sort become important, okay? And what you find is that those RAGs have emerged in quite a few different disciplines, okay? They give you much better answers than you get out of just the generic LLM, okay? What is also important in this is that having that telecom-specific LLM, okay, allows other disciplines and other verticals that require communications and communication systems, okay, to feed off of that, okay? And it's important for domain question answering, test case generations, network configurations, when you have dealing with problems, code generation, classifying problems, optimization, and predicting future states of the network itself, okay? Okay, and so I think likely one of our recommendations will be in this area on how to go and construct a telecom-like LLM.
So Adam, can I interject here?
Sure.
So there actually is at least one telecom-based LLM today that I'm familiar with, and it was formed by a company that I'm an advisor to named IRA Technologies. Yep. They call their LLM RAN GPT, so it allows the network operator to query the net and control the network through the use of an LLM. So it's exactly what you've been talking about. It was commercialized at the end of last year.
Yeah. So I haven't mentioned those. We have actually had a few SMEs, one of whom is coming back again. There are probably 6 or 7 outfits doing exactly that, okay? And I think that that's a good thing. Our suspicion is that there is a precursor state, okay, which requires a somewhat broader basis of what's actually in the LLM, okay? And what we find is, you know, when it comes to, let's say, the use of communications in either healthcare, automotive, Internet of Things, everybody's trying to play one of these sort of loops, okay? Communications plays a role in that. So it's important to have the hooks in what's built that are also applicable to other verticals, okay? And to recognize...
Excuse me. I think we need our slides back, if we could.
Yep.
Okay.
There you go.
Let's.
There we go. Oh, we're good. There we
Yeah,
go.
okay. So the point is that when you actually take a look at what we are discussing as an LLM, there actually is a telecom ecosystem, okay? And so that LLM may have sub-LLMs that are specific to various parts of that ecosystem, and they have to interoperate to be useful, okay? So if I were to look at it in the regulatory and standards area, very definitely. In industry itself, it's more than just wireless. It's fiber operators. It's the satellite folks, okay? On the research side, government labs, universities, other research labs, okay? And so it actually requires a high level of collaborators across a large number of stakeholders, okay? And so having a safe place to do that is fairly important. Okay, if we could then go back to where we were in the presentation. For 4.4.1. Okay. Okay.
I think that's it. Is that it?
Yep.
One before.
Yeah. But I have a feeling what I'd like to do at this point is maybe turn it over to you. Okay, Erdogan?
Can we go back to 4.4? Yes.
Okay.
Two before. Two slides before.
I think I'm on it. If you look there. One more.
Hello. It's a pleasure to present at this TAC meeting again. Thank you, Lisa. Before I go through the slides, I want to thank many of the experts, including TAC members and as well as external experts who have assisted our sub-working group with the work regarding our assigned charter items. I'm going to be covering 3 charter items that has been assigned to our sub-working group on Softwarization and AI/ML. So this charter item 4.2 is asking about the implications and also complications of using AI/ML in optimizing wireless and wired networks performance. We've made a number of observations regarding the implications and benefits of using AI/ML covering this slide. Just highlight a few of these implications here. And more is covered in the slide itself. One of the implications is dramatically enhancing the performance of networks. Another implication and benefit is minimizing failure rates of wired and wireless networks. And one important one is greatly reducing the operational costs of operating the networks. And specifically for the FCC, one of the implications is much better utilization of spectrum. Another one is greatly reducing the energy consumption of the national networks, which has been brought up a number of times today. And one important implication is also improving reliability, security, cybersecurity, and privacy of critical applications running on these networks. And can we move to the next slide?
I think you're there.
Thank you. As far as complications and challenges, we anticipate that deploying AI/ML will encounter some challenges, and we've listed some of those here. One challenge is establishing proper policies, legal rights, and also fair access to data as it relates to AI/ML. Another challenge is data privacy and security risks. The maturity of AI technologies is another one, including inherent flaws and how to eliminate them. Some examples are algorithm bias, model drift, and aging, and trustworthiness of AI/ML models. And there could also be issues with resource consumption. These include compute, storage, or power resources. As you know, AI/ML machine learning are significantly increasing the consumption of all of these resources. Finally, there are challenges and challenges with complexity in implementation of AI/ML in the network, as Adam was mentioning, the explosion of number of parameters being processed. So with respect to these observations, we've made a few preliminary recommendations to address both the promise and the challenges associated with AI/ML in networks. We believe there's a need for organizations and bodies that would guide interoperability and also develop and codify the network architectures that are using AI/ML. This is a role, as Adam mentioned, this is a role where FCC can serve as a convener and mediate the outcomes. This could be done directly or by working with existing organizations. Also, as AI/ML technologies continue to evolve, there is a need for a neutral guiding hand to help the players in the ecosystem productively interact and collaborate well together. There are two aspects here that we are emphasizing. One is with respect to the domestic side, to address issues that are unique and specific to the needs of the United States in achieving a few goals at the national level. This is regarding security, competitiveness, and technological leadership. And on the international side also to promulgate the use of the technologies in harmonizing global standards and interoperability across international markets. The next charter item 4.3 is asking how AI/ML techniques can be used to support integration and interoperability of wired and wireless networks. We've made a number of observations here as well. We think AI/ML techniques can play a critical role in enhancing the integration and interoperability of wired and wireless networks. And we've provided a few examples in this slide. One of them is AI/ML use in dynamic network configuration. For this purpose, machine learning can be used for automating network settings and optimizing resource allocation across the network. This includes mobile, core, metro, access, and local networks. This will ensure seamless operation adaptability to changing network conditions using AI/ML. Also, machine learning can be used for quality of service and quality of experience realization. Another example is using AI algorithms to help with improving network interoperability. One example of this is using AI/ML to optimize routing and managing connectivity through both wired and wireless channels. And finally, AI tools can also be used for network planning and network deployments, operations, as well as maintenance and upgrades. As related to those observations, we also have suggested here a list of requirements for enabling the use of AI/ML for integration and interoperability. I'm not going to go through the whole list here, but I will highlight a few of these key requirements. One of these requirements is to adopt standard interfaces and coordination across the whole telecom ecosystem, including operators, vendors, regulators, and other stakeholders. Another one is a need for curation and sharing of essential data resources across the telecom ecosystem, which Adam also mentioned earlier. And there's also a need for potentially a greater use of physical and information sensors to close the decision loop and loops driven by AI/ML models. So given these observations and requirements, we've also made a few preliminary recommendations for this charter item. I want to also note that the preliminary recommendations that we considered for bucket item 4.2 are also applicable to this bucket item 4.3. Additionally, we've made a few more specific recommendations for bucket 4.3. First recommendation is to accelerate experimentation venues, test beds, and demonstration projects shared across the US ecosystem. Our next preliminary recommendation is to promote policies that encourage open sharing of data resources across the telecom ecosystem. We are also recommending encouraging sharing of sensitive data for training and analysis, and also to mandate training programs on telecom-related AI, ML, and software skills. This is in order to train the skilled telecommunication national workforce at acceptable levels. And finally, we have a preliminary recommendation to devise new approaches to the regulations surrounding networks through testing and certification. So the final charter item for our sub-working group is this charter item 4.4 is asking how AI/ML techniques can be used to design and implement novel network architectures and protocols for wired and wireless networks, specifically as related to software-defined networking, SDNs, network function virtualization, NFVs, and information-centric networking, ICNs. We've also listed a few observations here. SDNs separate the control plane from the data plane in the network system, and they move the network management to a central point, the controller. And this allows for more flexible network management. Using AI/ML will significantly improve this flexibility by automating the decision-making process and therefore enabling intelligent SDN. NFVs are serving a different purpose. Network function virtualization is network architecture that virtualizes network functions. These are like firewalls, routers, load balancers, and they're all running on general purpose hardware. The architecture allows network functions to be deployed as virtual machines or in containers, or so-called containers, and then they can be shared by all network applications. And with that respect, AI is starting to play a critical role in NFV environments by automating complex network management tasks like orchestration and other NFV-related operations. Can we move to the next slide? Thank you. In summary, because AI/ML is enabling analysis of vast amount of network data that's happening in real time, this allows for intelligent decision-making, self-healing mechanisms, and ultimately creating more efficient and adaptable network configurations for SDNs, NFVs, or ISDNs, and this compared to traditional techniques. So as far as preliminary recommendations, we also think that similar to the previous charter items, the recommendations considered for bucket item 4.2 and 4.3 are also applicable to bucket 4.4. But in addition, the complexity of SDN and NFV networks are increasing because of an explosion of number of functional interface parameters running on the same compute platforms. And this is making a requirement for logical constructs of this type of networks to be compatible with the physical assets and their constraints. So we are recommending that it is increasingly important to have models that accurately project resource requirements and at the same time rigorously capture the risks to the networks and their overall reliability. And this is becoming even more important with the additional risks associated with AI/ML. So this concludes my portion. Yeah.
Great. All right, thank you. Mic back on. All right, so as we're wrapping up, we've talked about a lot of topics. We've got a fairly broad charter. There's a lot of exciting information there. Let's talk about transformation of the network. So how do we get there? There are several models that are emerging. Several different pieces of the industry are talking about it. I'm going to show you a few of the different models, and then we're going to talk about a model we may prefer. They're all very similar. So essentially, you look at multiple stages. Most have 5 or 6 stages. This model is showing you're exploring foundational. I think a key part in each maturity model is what is your proof of concept level. So everyone needs to go explore and figure that out, but it's time to get to a pilot project, proof of concept. I think in one of our past recommendations, we did call out a pilot project for the FCC to look at, and we call it get your feet wet and jump in. That's an important part of the foundational piece of AI development. And then, of course, going through stages until you get to full automation. There are different groups, different models, and for the sake of time, I'm not going to dive into these others, but I'm just pointing out it's important, the industry recognizes it's important, that we do have a roadmap or an architectural model specific to telecommunications that is going to help us evolve where we want to be. One that I think we're going to develop further here is this version of six levels of network autonomy and automation. And it's based on some of the same philosophies of autonomous driving, where essentially it starts with manual function, again, the important pilot stages, all the way up to full autonomy. And let's not forget we need a strong governance model as we get to full autonomy, and that gets developed alongside it as we are getting there. So in my final, this is my near final slide. So we're starting to lay out what might a telecommunications specific roadmap look like. These 6 levels of network autonomy that I just showed you on the slide that I described. And what years might they be? You'll still see question marks on there. We want to get more experts in. We want more debate within the group, more discussion. But I think this will show up as one of our end-of-year work products that we evolve with, which is something that helps guide on, well, what time frame are we really talking about? So that's the main content. I think what goes along with it is what's a template for an organizational journey? How do I start? It seems like it's challenging to get there, especially for large organizations. And I think that's also a piece of the roadmap. So what's our work plan for 2025? I think the key item will be a white paper, and we want that to be a deliverable. We've got the outline here. It's detailed in Appendix 8.7. It largely goes along these 4 buckets that has been our theme for this entire presentation. Buckets 1, 2, 3, 4. I don't need to re-speak about them because we've talked about them quite a bit. So we're looking forward to delivering that in August. And as I close, I just want to highlight it is a very long appendix with a lot of information. And Dean, thank you for thanking us for the information. Sometimes we wonder if it's too much, but there's quite a bit in there. And I would encourage anyone interested, anyone that's listening to this later, go give a look to this whole presentation, including the appendix. And with that, I'm finished.
All right. Thanks very much, Adam and Lisa. Questions, comments from anyone in the room, Mark, or online?
Yeah. One comment, and Ardavan had mentioned the importance of data privacy and protection and policies that we put in place. And we're reaching something new with AI beyond the fact that AI is doing things that we were doing. But now we're getting to the point to where all of our laws and rules and processes that we put in place, including the FCC telecommunication rules, every single rule says person or persons. And since we don't define AI as a person, none of those rules apply. So now that we're getting to the point where AI can do things that persons can do, we really need to take a look at that to make sure that we're realigning things to this. Because now we have something that doesn't fit the box anymore. All right.
Interesting. Rickon?
Yeah, Thanks, Dan, and I know lunch is served, so I'm going to be quick. On the 6 levels, you mentioned 6-level network automation. Is this something, the recommendations that your group has come up, or is this something taken from any of the academic research or white paper? And I did not see what you plan to do on those 6 levels in your 2025 plan.
Yeah. So what we did for that is actually followed what SAE had done, okay, for the 6 levels of autonomous driving, okay? Instead of control of the car, it was control of the network.
Oh, okay.
Okay. But eventually, if you look at the journey, it's to go to a network where the network is cogent enough that it is self-healing in many ways. Okay. And by the way, if I go back in history, some of the switches that were built by AT&T many years ago actually had those features. Okay. If it went down, it could reboot itself and come back up and figure out what was wrong. Okay.
Okay. No, thank you. And I have a request for your next presentation, like 3 months or whenever we meet again. I don't know if you have done this, but it would be good to see maybe if your working group can do an audit of all the ongoing or current research in academia, which are trying to look into applying AI, ML models into the spectrum sharing. You suggest that FCC should fund something like this. I don't know if NSF or other agencies are doing something like that.
Be very direct, okay. In fact, if you look at our share site of material, there's probably over 100 papers already in there. Okay? Okay? And by the way, I mean, we also have an extensive bibliography. I think it's got something over 400 books at this point in this area.
So I think that's a very good comment, and that's what I was alluding to. I think we're not ready to present that as the thing yet. We want to do more look, get more input, and make sure it's the right structure and right context.
Okay, thank you.
Thanks. Important point. I'm going to go to Henning, and then we'll come back to Peter.
Yeah, so one of the aspects that I was missing in the presentation is probably the most consumer visible part of use of particularly kind of generative AI chatbots in telecommunications, namely for customer support. I believe this has played a cameo role, at least in some of the recent tech support or recent customer experience NOI responses, for example, where I suspect all of us have been frustrated by the inability to actually talk to a human and deal with a chatbot, which in many cases has essentially created a 2-tier system of support. So business users or maybe higher tier paid users get real humans, and the vast majority of consumers have to struggle with whatever the quality of a chatbot is. I wonder if a committee, in order not to be seen as completely tone deaf to the consumer world, would want to actually look at those external applications, customer-facing applications about. Because right now this all seems like, oh, it's wonderful, it's going to do that, but most consumer experience with AI and telecom has, I would say, been, very politely, been a mixed blessing.
Okay, so let me do the following thing. We could have probably spent this whole presentation just on that topic, Henning, okay? So that's one. I think one of the things we try to emphasize, if you take a look at, I would say the first, let's say the softwarization view graph from Ardavan, here is the list of wonderful things, okay? And then, without being verbose about it, to say, but here are the problems. And one of them is really, what is the maturity of the technology? And when have you crossed the threshold that it's acceptable, okay? Because I think what you're saying is, in your judgment, that interface to the consumer, okay?
even though it says it's a chatbot, okay, is not satisfactory. It puts you into this endless loop. It's frustrating as hell, okay, and it gives you lots of misdirection, okay, which is one of the reasons I would say, and I think this comment actually came from Dean, okay, in the financial industry, for those organizations that are sensitive to the consumer, they've gone through great trouble to figure out how to, in fact, invest in the interfaces and the quality of what's actually done, okay? Because the fallout for them is too great. Everything from reputation risk to frustration of their consumers to causing a national panic, okay? So you're right on the mark. It's one of the issues. Okay? And so the cure for it is, how do you actually go through and mature the technology so it's acceptable and that it is used widely across the industry in an appropriate way? Okay? I don't think we have the answer to all of those. Okay.
Yeah, it just seemed to, given the dominance of that, I just feel like that report underplays that particular aspect.
Yeah.
It's a good point.
It's a fair point.
Yeah, and I do think the FCC is unique among maybe all other federal agencies and Congress, in the sense that the harms, the sort of fear that AI is going to destroy human civilization, I think is dictated the way almost every other federal agency is thinking about AI. And to her credit, Chairwoman Rosenworcel has taken a very balanced approach, not saying that there are not tons of things to worry about and potential abuses and all of that, but that there could be beneficial uses. And I give her credit for being really alone in highlighting that. And I think in other presentations that the two of you have made, you have incorporated that. And we certainly don't mean to say none of that exists. It's obviously just as in the potential downsides of AI and ML are just as important as the potential upsides. This presentation maybe was a little bit more on the focused on the upsides, but that's not to say that the potential harms to consumers in the telecom space don't exist. They do exist.
Yeah. So I think one comment, Henning, which I think is fairly important. And I think we took this on at the beginning of the year. We're actually quite conscious of the number of harms, problems in the AI space, okay? The flip side of it is there are now hundreds of organizations that are looking at that space that have much more depth than what we could do. And so we decided, I would say consciously, to focus on the network writ large, the changes in it, okay, as opposed to fixing all of the issues that I think other groups are better at this point, okay? So I think as context, and I think we said that in our very first presentation. Lisa, do you want to add anything to that? Or,
No, I think we covered safe use of AI quite a bit in past years, but it is very valid. It's a very valid point.
Yeah, it's just that the telecom environment is quite unique because of often the very limited competition that exists for a local consumer, where unlike what you just said earlier, that where banks have an incentive to test their things, the incentives are just maybe not quite as aligned in spaces where there's often a dominant provider for high-speed internet access.
Fair, certainly fair. Peter, last comment here.
I wanted to harken back to something that Lisa said, and just in the beginning to kind of take this down to the prosaic level on the network impact of AI. Certainly, initially in the previous discussion, we mentioned the impact of video upload on network architecture. But what I've been seeing in my own company is the impact of real-time location and using dense networks of beacons, specifically Wi-Fi beacons, which means large warehouses could have tens of thousands of network nodes rather than what we traditionally think of when we're thinking of data transfer. And this, while today doesn't seem to have an impact on the rules, it is something that we should monitor closely.
Okay, thanks. With that, thanks very much, Lisa and Adam, for yet another very comprehensive report. Thanks a lot. Next thing on the agenda, I think, is lunch. Martin?
Yeah, but before that, I just wanted to make not a comment to the AI group or the spectrum sharing group, but a general one. There's a question about economics and whether that's in the scope or not of the charter. Just to point everyone to the website, there's a ton of information in there about the Technological Advisory Council, including its charter and the working group charters as well. If you read the TAC charter, economics is explicitly called out in the charter. So folks shouldn't be concerned about not touching on economics, and in fact, it brings up aspects like competition, job creation, and overall greater efficiencies to benefit the American public. So just keep that in mind as you're working on your work items. Thanks.
Thanks a lot for that reminder, Martin. Okay, now we are on a lunch break. We will resume at 2 o'clock. Thanks, everyone. Thank you to the folks at Ericsson for a very nice lunch. So we are going to start up again with a presentation from our 6G working group. Brian Daly and Manu, take it away.
Thanks a lot, Dean. I'll get us started. Just a quick comms check.
Yep, we see you and hear you. Yeah.
Thank you. Yep, just waiting for the slides to come up. Thank you. Next slide, please. So I'm Abhimanyu Gosain. I'm from Northeastern University, and alongside Brian Daly from AT&T, we are the co-chairs for the 6G working group. Here's sort of a nice, healthy list of our team members. So as you can see, it spans quite a diverse interest group that is bringing their expertise to provide some of the updates, recommendations, advisements, and covering off a very broad charter that was assigned to us by the FCC. So it's been a lot of work, and really appreciate the participation and contribution both by the members as well as by the FCC liaisons. Next slide, please. So quickly, just running through the agenda, we're going to do a quick charter review. It was a pretty broad charter, so we'll talk about some of the areas that we covered this year, some of the areas that we have put on deck for 2025. We're not going to recap the August 29th meeting because we are providing a holistic update for the entire year. Brian then is going to talk about the state of the industry. This is basically looking and spreading a very broad aperture of all the different organizations, entities, alliances globally that are tasked with defining the next generation of communication standards. So we're not limiting ourselves to the moniker 6G. We're looking at what majority of these organizations are doing as we look at the next 10-year horizon. I'll give a charter topic update, basically pull from what we've presented in June and August, and then also some of the new updates since August. We'll then get into preliminary advisements, just bottom line up front. These are going to be advisements at this point, since we need to refine and provide actual recommendations at the end of the charter, somewhere in the September time frame. And to that effect, we will talk about our proposed plan for 2025. We'll acknowledge all the subject matter experts and external contributions we've heard from and we have leaned on to provide some of these advisements and charter topic updates. Next slide, please. Next slide. Thank you. So yeah, so these are the charter topics that we were assigned. Again, as you'll see, it was quite a broad agenda. So what we have been able to cover and do a meaningful enough job in covering those charter topic areas, and just to sort of pull back the covers from how these how we chose these topic areas to cover in 24 versus push some of them to 25. This was again a collective effort by the membership group to look at which areas have some level of technical advancement, or where we can find literature, material, subject matter experts, and form certain opinions on this technology as it relates to the concept of 6G. And the ones that were not mature enough, we have deferred them to next year. And some of the ones that you see on your slide, primarily around the development and deployment of 6G technologies and providing certain insights on what the expectations are from technology and regulatory perspective. So you'll hear some of those updates in that state of the industry that Brian's going to present shortly. We do a very deep dive in how 6G has been progressing at standards and international fora, and what are sort of some of the key points that we're seeing emerging. And also lightly touching on some of the 6G visions, and primarily our sample size is going to be from this 3GPP SA1 workshop that happened in the May timeframe this year, where multiple different agencies and alliances came to put forth their technology use case and vision statements for 6G. Next slide.
No, I had 3 cups of coffee today. I don't know.
Oh, I think we have a little hot mic. Okay. In addition, we then go down into specific technical topic areas. We're going to cover some of the areas around millimeter wave and terahertz for 6G systems. We're going to talk about really, this was a lesson learned from discussion in the group, which was to really look at what the use cases that are driving 5G and what will be the use cases and different various verticals that will drive 6G in the future are going to be. So we will do a deep dive across each of those topic areas that you see listed on those slides. We'll talk about high volume, massive volume mobile and IoT devices. We'll also talk about some of the low latency applications, specifically around AR, VR, and XR for near and non-real time application support. We also talk about visible light communication, and this is again a very forward-looking topic area as it pertains to communications, but we have some good material from our subject matter expertise that presented to the charter group. Next slide, please. So things that we've deferred a little bit to 2025. We'll touch still on some of these topics in today's updates, but primarily to do justice to these points in terms of actionable recommendations, we put them in this bucket for coverage in 2025. So we'll obviously talk about some of the openness and customization capabilities, infrastructure needs of 6G. Obviously, that's going to go hand in hand as the technology development begins to progress, and then how we can provide some actionable recommendations to the FCC. We're going to look at and we'll look very carefully at this privacy and security risks for 6G networks, specifically around the data collection and processing piece. A lot to be learned by the excellent presentation earlier from Adam and Lisa. So we will sort of take that to bear, and then also see how this notion of privacy and security emerges on more consumer-facing applications like brain-computer interfaces and holographic communications. Again, that theme continues, specifically at looking at physical layer security, distributed ledger solutions, as well as quantum communications, which we believe will be better suited for covering in 2025. Next slide, please. And then we have small satellite developments and NTN. Again, this is learning a little bit from what are some of the frequency bands, as well as what the hybrid architecture approach for including NTN into 5G and 6G is going to look like, and what kind of services, including direct-to-device, will be enabled. Next slide, please. So now I'd like to pass it over to Brian to sort of give us a broader perspective, as I said earlier, across different industry bodies, alliances, and with that, I'll pass it over to you, Brian.
Thanks, Manu. So we'll start off with the state of the industry, and when you talk about the state of industry for mobile telecommunications, you have to start with the ITU. So the ITU process has been underway, as you see on the bottom chart, since 2021 timeframe, all leading up to what's known as IMT 2030, or better known as 6G when we come to the 3GPP standards. So there's a lot in between that has happened since the start of the development of the future technology roadmaps. There was a recommendation on the new framework for IMT 2030 and beyond. And currently what's being developed is the technical performance requirements to meet
that that framework that was put together back in the 22 to 23 timeframe. Those technical performance requirements are going to be what sets the base for 3GPP to define the standards and specifications that come out of 3GPP that ultimately will feed back into the ITU for the evaluation of those specifications to see if it meets the criteria that's being defined to meet the performance requirements. That evaluation criteria and methodology, as you see, is just getting underway and will continue through mid-2026. At that point, those templates that will be used for the evaluation will be available to the industry, and the technology proposals will be submitted back to the ITU for the evaluation process. And ultimately, if it passes the evaluation, they'll come out as an IMT 2030 specification. So at the bottom, just to summarize, the framework was defined. We're in the requirements and evaluation criteria definition phase. After that will be the evaluation and consensus building, followed by the specification and specification approval. As you can see in the top left-hand side, this is no different than what was done for 5G or IMT 2020, as well as previous generations of IMT technologies that were developed by the ITU. And as you can see on the right-hand side of that top figure, that future work is what's left to do in order to define IMT 2030. Next slide, please. So within the framework, you've probably seen these two diagrams, the wheel and pallet diagrams that have. Yes? Oh, it must be background noise. So the wheel diagram defines the usage scenarios for the overarching aspects of IMT 2030. And within there, we have extensions from what was done in 5G, in enhanced mobile broadband, enhanced massive communications, and ultra reliable low latency communications. So we bring the enhanced mobile broadband into a more immersive communication environment and more massive IoT devices on the network and hyper reliable and low latency communications than what we had in 5G. And this also adds 3 new usage scenarios for ubiquitous connectivity. As Manu mentioned, one of our charter items is to look at NTN and satellite communications that will support this ubiquitous connectivity goal for 6G. And of course, AI and communication and the intersection between the two and how that will come into play, as well as integrated sensing and communication. There are 4 overarching aspects as we look to IMT 2030, and that is to act as design principles commonly applicable to all usage scenarios, being sustainability, connecting the unconnected, ubiquitous intelligence, and security and resilience. The palette diagram on the right is the start of the performance requirements for IMT 2030. And again, I mentioned the start because if we go back to the IMT ITUR timeline and process diagram, diagram, what we'll see is that performance requirements are underway, but they haven't been completed yet, and they'll continue throughout next year and into early 2026. But we do have some idea on what the enhanced capabilities that are being looked at for IMT 2030 and some ideas on the performance requirements for them, as well as the new capabilities that are being brought into IMT 2030. And those are all shown on this palette diagram. And also what we see are 9 trends as we look towards 6G. Ubiquitous intelligence, ubiquitous computing, immersive multimedia and multisensory interactions, digital twin and virtual world, smart industrial applications, digital health and well-being, ubiquitous connectivity, integration of sensing and communication, and sustainability. So those are the 9 overarching trends that we're looking at as we move toward IMT 2030. Next slide, please. And of course, 3GPP will define the mobility specifications for the IMT 2030 requirements. 3GPP has already started the 6G study in the requirements group, or SA1, for Release 20. The Release 20 content, however, is not decided yet, and that'll be decided in the first half of 2025. And that's actually going to be split into two different developments chains. The first Release 20 content definition will be a continuation of the 5G advanced development. And independent of that, there's going to be 6G work. The decisions and the work between 5G advanced and 6G are going to be made separately, and obviously will take into account the needs of the evolution of each of those technologies. There is going to be a 3GPP workshop on 6G that is going to be held in March of 2025, and this will define the vision and priorities for the next generation. And it'll include both the RAN, radio access network, the system architecture, the core network, as well as the protocols. So it's an all-encompassing workshop that's going to cover that vision and the priorities as we look towards 6G. I mentioned a lot about Release 20, defining the study items for 6G. Well, Release 21 will have the specification work on 6G, and ultimately it's envisioned that Release 21 work out of the RAN working groups will be the basis for the IMT 2030 submission. And as I mentioned, one of the process that the ITUR has is once the specifications are complete in one of the industry specification setting organizations, those specifications then are brought back into the ITU for evaluation against the performance criteria. And then if the performance criteria is met, it then gets published as an ITU specification. And again, that's only on the radio access network side. Next slide, please. So I mentioned there is a 3GPP SA1 study underway. And I want to emphasize that what I'm presenting now are very early insights into what's contained in that study. And that study will continue. So a lot of this is subject to change, but I wanted to give a flavor of what they're looking at. The first is network security. And as we're aware, it's expected that cloud deployments are going to play an important role as we move towards 6G. We need the 6G network to provide trust and security mechanisms for secure access to and communication with the various network elements. And it has to provide security protection for communication against the potential attacks posed by quantum computing. For AI, again, the 6G system is going to be built on the cloud, optimized for ubiquitous computing, and natively provide computing services, like in the forms of infrastructure services, platform services, and software services. By incorporating these standardized interface, as well as robust security protocols and advanced resource management frameworks, 6G can facilitate efficient and secure access to network resources. So accessing those network resources in a secure way is going to be essential as we move towards 6G. And we want to position those networks as comprehensive platforms for distributed computing and AI services, and also align with the demands of the evolving technology landscape and provide resource as a service. We've heard a lot about integrated sensing and computing, and we'll dive deeper into that as well as we move into our charter items in 2025. Looking at wide area multidimensional sensing will provide spatial information about unconnected objects as well as connected devices and their movements and surroundings. And there are many example use cases, but a few are coordination of search and rescue missions in large disaster areas, safety assistance for vulnerable pedestrians, as well as high-resolution topographic maps and low-altitude uncrewed aircraft supervision and traffic management. So integrated sensing and computing is one of the focus areas and new areas that is being looked at as we move towards 6G networks. Next slide. I've already mentioned about ubiquitous computing, ubiquitous connectivity, excuse me. They want to ensure that all locations, including those remote areas or those areas that have challenging geographic conditions like mountains, forests, and so forth, that aerial operations and as well as open ocean are covered by the mobility network connectivity. And this can be realized using a combination of both terrestrial networks and non-terrestrial networks. And when we talk about non-terrestrial networks, we don't only include satellites. We also include high-altitude platform stations, or better known as HAPS, as well as air-to-ground networks and unmanned aerial vehicles. We want to do this in a transparent manner for the end user so that we can fulfill QoS criteria such as bit rates and latency that the user will expect no matter which network is providing their access. Also, we're looking at resilient positioning in satellite networks. There is a dependency on satellite for positioning, and that could result in major threats and risks in the case that the satellite network is unavailable or is disrupted in the cases of jamming, spoofing, or just obstructions. The 6G system, which will have satellite access, could provide a positioning service with the 3GPP technologies rather than using independent non-3GPP positioning technologies. So resilience positioning is another area that is a potential for 6G. Immersive communication, looking at interactive gaming, seamless immersive reality in education as a number of example use cases. Fixed wireless access, again, with 5G, we're seeing more and more support for fixed wireless access. That is being brought into 6G to provide optimized network capabilities to support fixed wireless, including the support for stationary devices. And finally, sustainability is a major theme to improve energy efficiency of 6G and especially more energy efficient over 5G systems. Next slide, please. The O-RAN Alliance is also looking towards the next generation as well. There is planning underway for an O-RAN Alliance 3GPP workshop in April of this year to discuss how the O-RAN's open interfaces and architecture can be harmonized with the 3GPP protocols. We want to ensure seamless integration and interoperability between 3GPP and O-RAN systems. And the solutions that are being developed by both organizations, and especially the use of AI ML for network automation, optimization, and intelligent management. That would span across both open and traditional RAN, so coordination is especially important as we look toward AI and ML. This workshop will help define the vision and key requirements for 6G and build upon the foundations that have been done in 5G, as well as the Open RAN principles. ATIS has also created an Open RAN committee, and the purpose of this is to examine Open RAN and Open RAN topics with the use and deployment of Open RAN in North America. The goal is to evaluate O-RAN Alliance specifications for possible transposition into ATIS standards. That's very similar to what we do in ATIS with 3GPP standards. They are transposed into ATIS standards and then become North American standards. This transposition process could also be brought and provide North American standards for the ORAN specifications, and also can be analyzed to see if there's any changes that would be required to meet unique North American requirements that could be brought back to the ORAN Alliance for consideration. Next slide, please. Moving away from 3GPP a bit, as Manu mentioned earlier, we want to take a holistic approach to what 6G might be. And, one automatically leans toward ITU and 3GPP, but there are other technologies that are involved in future generation or future technology evolution. And one of those is the IEEE Future Networks Technical Community. Looking at their vision to address strategic areas of interest of evolving communication needs across different time horizons. The figure shows on the left side is the radio access network, in the center is the core network, and on the right is other external networks. There are a number of projects within IEEE that are looking, for example, a standard for massive MIMO architecture framework, as well as the standard for communication architecture functional framework for smart cities. All of these are complementary to 3GPP specification definition, and will support specific areas of interest beyond what 3GPP is doing, and basically provides a complement to those specifications that'll benefit for the entire ecosystem. Next slide, please. The technical community within IEEE Future Networks also has an IEEE 5G, 6G innovation testbed. And this testbed will bring together participants across a broad range of 5G and 6G technologies to enable a win-win collaboration to look at various roadmaps for technology evolution. It's a cloud-based end-to-end 5G network for testing and innovation. Looking at various use cases, including interoperability and conformance testing, load testing, sandbox innovation, proof of concept, security testing, and more. And it allows, to connect various hardware and software components to be tested against one another. It does help to reduce the cost of experimentation and development for interdependent industry players, and that'll help speed up innovation in a time of cost cutting. The opportunities also exist for academia to use this testbed as an education tool, workforce preparation, and for research or capstone projects. And again, it's open worldwide for any industry or academic organization to participate. Next slide, please. So there are also some US government efforts around 6G. And if we go to the next slide, please. So looking at the National Security Council, they released the Principles of 6G Open and Resilient by Design in April of 2023. I'm not going to go through each of the chapters of the document, but as you can see, it does have some major themes on open and interoperable, secure networks, affordable, and spectrum is a main theme, as well as standards and international collaboration. There was the National Spectrum Strategy, also released in 2023, that had 4 pillars. The first being the spectrum pipeline with 5 bands for study, long-term planning for spectrum needs, spectrum innovation, and expanding the spectrum expertise and elevated national awareness. And the last document is the National Spectrum Strategy. And this had 8 priority areas, including 4 directly relevant to future networks. And I think I said spectrum strategy, it's a national standard strategy. The 4 areas are communication and networking technologies, semiconductors and microelectronics, artificial intelligence and machine learning, and positioning, navigation, and timing services. Next slide, please. In 2023, there was a World Radio Conference And out of that came some various spectrum perspectives that we should be aware of. The resolutions likely impacting 5G advanced and 6G include the identification of 3.3 to 3.4 gigahertz for IMT, the upper 6 gigahertz band, also identified for IMT, not only for EMEA, but also in Mexico, Brazil, and some Asian countries. And there's recognition of the use of wireless access systems for some countries is also part of the identification deal. And the top 100 megahertz was identified for IMT in the Asia Pacific region. Potentially additional countries in the Americas and Asia Pacific can also join the upper 6 gigahertz band. There was a new IMT 6G agenda item for the World Radio Conference in 2027 that was approved and gives a positive outlook, enabling suitable studies to be conducted. And the bands agreed for studies are 4,400 to 4,800 megahertz in EMEA and Asia, 7125 to 84 megahertz, excluding a portion of that that's used in Europe by NATO, and 14.8 to 1535 gigahertz globally. The U.S. had positions in Work 23, as well as the National Spectrum Strategy, including 3.1 to 3.3. And the DoD has determined that sharing is feasible if certain advanced interference mitigation features and a coordination framework are put in place. Also 12.7 to 13.25. And they're considering options for the use of 12.7 to 13.25 band, which has in-band and adjacent band federal operations that may need to be protected. And the National Spectrum Strategy also proposed additional bands for further investigation, including 7.125 to 8.4 and 37 to 37.6. 7.125 to 8.4 is the only common range between the World Radio Conference 27 agenda items and the National Spectrum Strategy. So with that, let me turn it back to Manu for continuation of the charter topic updates. Manu?
Thanks, Brian. Next slide, please. So here let's get into a little bit of next level of detail of what Brian gave as a very nice overview across what was happening in 3GPP. So just to continue that a little bit deeper, delving into this 60 use case workshop that was held in May. This was a workshop that was sort of the kind of the first step in trying to understand what some of the use cases that 6G would look at. And kind of like the going in assumption here is to try to understand, again, a wide diversity of use cases that could be supported by this technology and kind of work its way into how the technology development curve and the roadmap of activities should be undertaken, primarily first by looking at what are the requirements that are coming from a diverse set of use case stakeholders and providers. So this was a collaborative effort, and this was done under the auspices of the SA1 group. Had a significantly good participation of 200 participants and also a large contingent remotely. I'm not going to go over the list, but there are multiple different acronyms that basically represent a global consortia and global special interest groups for multiple different topic areas, some highlighted around satellite, automotive, multimedia, public safety. Not only that, this was also an opportunity for global players and nations to come with a collective vision for 60 use cases. So countries such as Japan, South Korea, China, India, as well as North America represented by the ADIS NextG Alliance, as well as Europe and the 60 SNS program were there. Again, important to recognize that this was not any kind of a priority or a ranking or adoption of any specific use cases. This was primarily at a workshop level to understand what the aperture is for different kind of use cases. Next slide, please. I wanted to credit the NextG Alliance for putting together this this summary.
which basically distilled a lot of the different common themes and potential drivers for the different use cases that were presented by each group that had an opportunity. So as you can see, security, and this very nicely aligns with some of the preliminary topic areas that have been undertaken by 3GPP, as Brian alluded to earlier, which was around security. So network security seems to be something that corresponds and resonates very strongly with the global community as being an inherent feature or a defining item for what 6G is going to look like. AI received a significant amount of interest, and obviously we've seen the proliferation of AI in certain aspects of the network, but the goal will be to look at multiple additional study items across AI in the radio access network, in the core, in service management orchestration, and beyond. Some other themes that emerged were around sustainability, as well as ubiquitous and resilient coverage. Again, this is a theme that we've seen some of the technical study items, the preliminary ones that we just saw. Sensing is going to become important, and we saw integrated sensing and communications given its own pillar in the 6 pillars in the 6G hexagon we earlier saw, and this obviously also resonated with the broader group. In addition to that, the ones that didn't necessarily, and again, if you're not seeing a check mark or a significant number of check marks along the column line, it doesn't necessarily dilute the need or focus, for example, for fixed wireless access or for low-powered devices. It's essentially just in the context of 6G, what was presented at this workshop. Positioning, as you see, is also extremely important, and we will brief a little bit more about what we've learned about that ecosystem and what are some of the additional opportunities beyond how 6G can help in positioning beyond just using the GNSS global satellite system. And again, this is a non-exhaustive list, but it basically represents the interests across communities for this. So again, appreciate the NextG Alliance for providing this comprehensive analysis. Next slide, please. So switching over to, we heard about IEEE. I'll switch a little bit more, dive straight into Wi-Fi. So we had the Wi-Fi Alliance and representatives from IEEE 802, and this was to answer the questions around progression of 6G at other fora that is beyond just 3GPP. So seeing a tremendous amount of work and excitement in the IEEE working groups, close to 200 plus working groups that are looking to continue IEEE 802 standards, the Landman Standards Committee that are covering both wireless and wired, and also on a key focus on the link and physical layers of the network stack to obviously increase capacity and lower the latency, and then also twinning with the IETF protocols for the higher layers of the protocol stack. In the 802.11 realm, there was significant amount of work that was done and that was presented and shared with our group, which was primarily at increasing the throughputs in the 2.45 and 6 gigahertz bands, which is colloquially or generally termed as Wi-Fi 7. Seeing a significant amount of interest in wireless sensing and primarily for indoor positioning and localization, as well as data privacy and longer range over a larger swath of bandwidth. And with that, looking at working groups for ultra-high reliability, as well as low power or ambient power battery-free communication. Next slide. Also seeing a significant amount of work for addressing throughput, spectral efficiency, and low latency through enhancements to Wi-Fi. So this is specifically working groups in 802.11be that are looking at wider channels up to 320 megahertz, better modulations at 4096 QAM, and backward compatibility with ABGN standards. Sensing, again, it's the trying to use these wireless signals to detect features of a target in a given environment. And then most importantly, also seeing a proliferation or at least a study for AI and ML under the AI/ML Standing Committee, which is looking at the applications focus on performance improvement, parameterized selection, channel usage, and improving the transition between the links as well as link adaptation. Next slide, please. So switching gears a little bit, and this is where we'll spend a little bit of time, which is around what is the envisioning for 6G technologies across various verticals. For that, the way the working group looked at it was primarily looking at what 5G has done and what the current state of the art is. So from a standardization perspective, again, the work in 3GPP continues, and there have been a numerous amounts of specifications that have been developed in enhancing and improving the 5G NR standard towards different vertical areas. V2X and automotive has been very vocal and most notable. However, and that's primarily looking at it from the URLLC side, which is the ultra reliable low latency communication. But what we have seen is the bread and butter has primarily been EMBB enhancements, enhanced mobile broadband enhancements, where the focus has been on increasing the data rate coverage and lowering the latency, and also looking at this issue of addressing the refresh cycle associated with the end devices or smartphones. And that deployment, specifically in the automotive sector, is ongoing. In terms of evolution towards 6G, this is, again, about unlocking value and unlocking new use cases, as well as new services in a more cost-effective manner. So this is, again, pushing the envelope beyond what 5G and 5G Advanced is trying to prove out, and look at it in the early days of the formation of the 6G technology as key input criteria. This also helps leverage different components of the automotive vehicle to deliver these services, and also looking at enhanced services in a cost-effective manner using a reuse and synergy concept. Next slide. Okay, so in the automotive sector, looking at the requirements, obviously the key piece is connectivity, and ubiquitous connectivity is going to be key. Again, this is a first order consideration for 6G networks, but primarily coming from what the needs are or what the requirements are around secure, reliable, resilient, low latency, and high mobility communication for advanced driving remote vehicle services. And enhanced communications, obviously, for in-vehicle applications like immersive media, immersive infotainment applications, and also pedestrian protection by providing improved location information, sub-meter area. So these are sort of the key driving factors for the automotive sector as it pertains to mobile communication technologies. And then in terms of the enabling 6G technologies for this, these are looking at resilient communication improvements for functional automated driving services, improving the service continuity. So this is about looking at integration of public and non-public networks, as well as a hybrid terrestrial and non-terrestrial network architecture, sensing capabilities in and around the vehicle, leveraging the concept of ISAC that continues to be developed, as well as the antenna placements for the vehicle by studying refractive meta surfaces that will provide a key use case to increase adoption of 6G technologies for automotive vehicles. Next slide, please. Okay, switching gear to some complementary technologies. So ATSC and its newest avatar, ATSC 3.0, again, it was adopted by the FCC primarily to enable a convergence with broadband streaming. And this is, the new generation that has now a better or using a COFDM technology and doing data casting using this new standard. So again, this enables a low latency push of information or TV broadcast, both in high definition and ultra high definition to all devices in a metro area, and allows for reliable and time-sensitive communications in congested environments, and is seen as a complementary technology to cellular and broadband. On the right, you see the signals and the coverage areas for multiple different households in CONUS. Next slide, please. And some of these benefits of how this technology can be complementary is in the notion of content offloading, which is the ability to integrate whenever there is a capacity surge on cellular or broadband networks to offload content and improve network efficiency. Hyperlocalization, given that these networks are targeting local and metro areas and targeting broadcasting transmissions, which will enable multiple different use cases. Also helps with the positioning piece and localization for emergency alerts, as well as personalizing content and increasing the network capacity by providing an alternative network path for routing data to the end devices, helping decongest the data pathways anytime there is a cellular coverage overload, and increasing or improving faster download speeds. So the 6 megahertz broadcast channel that can reach or match traditional broadband up to 50 megabits per second. Next slide, please. So this is again in seeing this data casting with in action using an ATSC receiver, and some of the use cases that are listed below, primarily around digital signage, map updates, media services, connecting cars, as well as the agricultural domain. Next slide, please. So this is a presentation that we had from the U.S. Department of Defense, which represented a case or made a case for open architectures, which was one of the charter items that was that we were tasked to look at. And this was quite an interesting concept, where a notion of building a open source, open access, end-to-end radio access network that's leveraged this disaggregated open radio access network, or open RAN concept, and building these components that can be available both to a government and a TOT user, but also to the commercial ecosystem. And this is a work that is being done by the Future G Office at the Office of Under Secretary for Defense. This is tying in some of the significant investments that the CHIPS and Science Acts have made in terms of building high-performance hardware, and also increasing lab to fab in terms of improving hardware capabilities, radio capabilities, as well as compute infrastructure capabilities. So leveraging that open paradigm, the notion of building this open source software stack that will be available both on the government DoD side, but also helping accelerate commercial adoption, as well as allowing academic users, and also leveraging or using this to influence standards, because now you have a baseline test and reference environment that allows you to build and explore certain architectural principles that are coming out from the standards. So some of the key benefits listed are around security, which is basically due to completely open observability of the stack, both horizontally and vertically, customizable, meaning that this can be customized to the needs, whether it be for a kind of a edge case or an extreme use case, such as a DoD tactical environment, mission critical need, or public safety side, or for other government users. And interoperability, meaning interoperability with the public network, and interoperability between the different components of a disaggregated 5G, 6G radio access network. Flexible, transparent, cost-effective, because this is again secured by design, and putting this in a open source domain allows multiple developers and multiple ecosystem community partners to contribute, that helps drive this innovation. So this is a capability that the DoD hopes to embark on, and the tagline here is to affect 6G standards, or the development of standards, through the open source alternatives. Next slide. Switching gears again to back into the different domains and industry verticals, we're going to look at AR and VR. So AR, VR, XR use case requirements. Just to begin with the definition of the generalized term, which is around spanning both the physical and virtual worlds, and sharing the space with virtual reality, as well as digitally enhancing a physical space with augmented reality. And then in terms of personalized digital experiences with XR. So that's sort of the aperture of what these different use cases enable, which is a mixing of both physical and virtual worlds. A key term that we learned was around this notion of motion to render to photon latency, which basically has to do with compute processing at the edge. And here is where the communication paradigm becomes extremely important, which is the round trip time.
as well as the device processing on the end user device. And the idea is that this latency is something that needs to be managed so that the experience to the end user is not discernible, and they have a nice QoE. This also sort of requires a significant amount of network capacity increase, not necessarily to the core of the network, but really at the edge and down to the user level, and also significantly high bandwidths per user, up to 10 gigabits per second. Some of the drivers are immersive interactions, digital interactions that will take human augmentation to the next level by providing ubiquitous low-powered access and specifically joint communications and sensing, as well as immersion in 3D digital content, digital twins, which we are seeing significant both on the network planning side, but now also digital twins, which help make complex renderings of the physical world in the metaverse. So that's primarily coming from what are the key requirements and drivers for this industry vertical. Next slide, please. So what's happening with respect to standardization or some of the additional enhancements? It is a very active area of work, starting from release 15, 16, and certain enhancements that have been made to handle some of the key constraints that these applications bring, or the network load that it adds, and in terms of increasing power efficiency and handling device latency. Some of these study items are looking at staggering traffic arrivals at the G node B, doing kind of a sleep after a low latency uplink transmission, and trying to think of new areas for low latency mobility. So as you see on the picture, from the infrastructure side, on the device side on the right, to the infrastructure side on the left, and certain key features that are being considered and worked on for enhancing and increasing adoption of 5G, 6G technologies in this area. Next slide, please. So getting down a little bit into the technology updates. So we looked at which, and this is a term that the group came to consensus with, which we are terming simultaneous in-band transmit and receive, or in short, full duplex. Full duplex, again, technology has been around, but in terms of seeing significant adoption, we really wanted to study this, and we had a few different subject matter experts come and talk to us about it. The key issue with full duplex, as most of us are aware of, is around self-interference. And the idea is the mitigation principles are around cancellation or suppression of this self-interference, so we can use the same band for transmit and receive in that same band. Some of the issues are around some of the analog architectures that we've seen up to today, which don't necessarily scale well with the massive MIMO or with the array sizes of the MIMO antenna systems that are being built for 5G to provide coverage and capacity. Some of the ADCs, or the analog digital converters in the RF chain, are also falling off the Moore's law curve in terms of the improvements around them. And then the issue is around the deployment within a brownfield environment and some of the TD changes, the time division duplexing configuration changes required to support this technology. Obviously, the benefits are immense, which is to increase the data rate, as well as for high transfer applications, and also unlock a potential in joint sensing and communication, which allows us to use the same channel for both purposes. Next slide. We dug a little bit deeper and looked at the standards, and this was a technology proposal presentation that is being driven by Qualcomm, which is the subband full duplex technique, where, again, not to go too deep into the technology, but the idea here very simply is a component carrier bandwidth that is split into non-overlapping uplink and downlink subbands within the same main band to enable simultaneous transmit and receive on the G node B side. And leveraging the benefits of full duplex communication while reducing interference mitigation. So it is adopted as a study item in release 18, as well as in the currently in the specification phase for release 19. Challenges, again, are to maintain the self-interference, or to and also the clutter echo.
So the idea here, the issue here is the cross-link interference that happens between the G node Bs as well as between the UEs. Benefits again are around enabling these new use cases and helping further latency reduction and higher throughput, which improves coverage and latency. So this is an exciting area, and we'll continue to monitor the evolution and development of this technology. Next slide. So positioning is very important. I think Brian earlier alluded to it, and we've heard some references to position. Here in the U.S., as leaders of GPS, we are seeing significant international advancements and competition, seeing multiple different constellations for position, navigation, and timing that have been that are now circling the Earth. Baidu from China, GLONASS from Russia, and Galileo from the EU, and these are now providing competition to what is available as part of the global positioning system. Of course, competition in some parts is healthy, but PNT is extremely important and sensitive in terms of providing it for mission critical needs for the general global economy. So it's very important that in the 6G realm, we look at building and improving position navigation and timing resiliency. So how do we sort of build multiple different failure modes? How do we protect PNT systems from jamming and interference? And some of the benefits of 6G and integration will be to enhance navigation and timing accuracy across dense urban areas as well as in indoor areas, which helps sort of alleviate some of the reliance on satellite-only systems that may be vulnerable to external threats, jammings, which we have seen in some of the conflicts that have been arising globally. And the idea here would be to sort of leverage some of the late-stage 5Gs to do some initial testing and refinement of these resiliency approaches. So that is going to be a key area and will most likely encompass one of our advisements back to the FCC. Next slide, please. So Brian, I'll hand it over to you back.
Okay, thanks, Manu. So as we move forward, we have, as Manu mentioned in the opening, we do have a number of preliminary advisements at this point. As we've stated many times, 6G is in its early stages. There's a lot of work ahead, and it's going to be really starting in earnest in 2025. So at this point, we have some preliminary advisements really to focus on that initial work that's going on in 3GPP. We should monitor it. Specifically, the continuation of the SA1 study on 6G use cases and service requirements, which we highlighted, some of the preliminary findings during this report. We want to look for insights into the potential use cases that are going to be developed in 3GPP Release 20 and what those implications might be to telecommunications policy. We should also monitor the outcome of the workshop that is occurring in March. And again, this is the workshop that will span across RAN, the service architecture, the system, overall system, end-to-end system. And we need to also look at the joint ORAN 3GPP workshop that is targeted for April so that we can gain insights into how the specification evolution is going to march towards 6G. And finally, there are new service delivery opportunities for 6G networks that we've already identified and talked about. The first being integrated sensing and communications, or ISAC. We've talked about native AI in the RAN and also the non-terrestrial network integration topic areas. So those are three advisements that we'll bring up at this point. Especially as we move into 2025 and continue the work as we move along. So with that, if we go to the next slide, so our final deliverable is due in September. We will continue our working group meetings, which are from 4 to 5 p.m. Eastern time on every Thursday. And we will monitor and report on the work in 3GPP, especially the 6G study, the March workshop, and the joint ORAN 3GPP workshop.
We have additional subject matter expert presentations lined up to address the charter items. And specifically, we're going to focus on millimeter wave and terahertz, public safety, positioning and timing, integrated sensing and communication, as well as the Open RAN and 3GPP alignment. So that concludes the presentation. We do have a summary of the SME presentations included in the deck. Again, we're not going to go through each of those in here. I think we've talked about the majority of them. Manu, unless you want to go through in any of these?
No, I just wanted to, if we just want to run through the slide, just wanted to acknowledge, all the different experts we've been able to see. So it was, it was more an acknowledgement than anything, and we've summarized that just for the sake of completeness, so it'll be available to the rest, but nothing else at this point.
Very good. So that completes our report. Thank you very much.
Hey, thanks so much, Brian and Manu, for yet another fantastic, comprehensive, extraordinarily comprehensive report. I had one thing I wanted to comment on, which is great to see the focus on ubiquitous connectivity. Great to see that the ubiquitous connectivity is not solely cellular, and that you're bringing in, that the idea is to bring in all the various delivery mechanisms. I would just like to emphasize again that there is no part of 3GP necessarily that focuses on lowering end-to-end cost, but lowering end-to-end cost, having the end product be something that has reduced end-to-end costs is crucial. It's crucial for solving the digital divide. It's crucial for ensuring that that the technology that's developed not only meets all the important performance requirements, but that that it's going to be commercially viable. So I just wanted to put in a plug for that. I also thought it was great that the workshop is happening between 3GPP and ORAN. One of the questions I think that we've discussed in the past is kind of the intersection between 6G and ORAN, and making sure that ORAN is, that 6G rather is kind of ORAN native or built for ORAN from the ground up. And it's great to see that that is something that's, that the work is progressing on. So I just wanted to put that, especially the end-to-end cost out there in the mix. I know it's something that Chairwoman Rosenworcel, solving the digital divide, has been a huge priority of hers for years. It's been a huge congressional priority for years. Other comments or questions? Anything online? No. Okay. Well, then Brian and Manu, great job. Thanks very much.
Thank you.
Thank you.
So thanks, everyone. So at this point, we are through our working group presentations. I have kind of a quick, I hope it'll be quick point of personal privilege, which is to say the following. So it's been absolutely my honor to be the chair of the TAC for the past 3 years. I've enjoyed it immensely. I'm very, very grateful to Chairwoman Rosenworcel for asking me to take this on. It's been great working with Martin, Sean, Ira, Ron Rapazzi, Michael Haas, Sharon Kelly, the whole FCC staff. So some of you have asked me what's going to happen with the TAC post-January 20th when Commissioner Carr becomes the chair of the FCC. So I think, as Martin explained, since our charter carries over into September, the working groups can meet in January. There's no necessarily sudden change that we know of right now. Under the FACA incoming, once he becomes the chairman, Brendan Carr can make changes to the charter. I have no idea whether that's anything that's in his to-do list or not. But speaking for myself, I'm going to join Chairwoman Rosenworcel and depart from this role as of January 20th. I think Brendan should be able to pick the person that he wants to lead the TAC, just the way Jessica Rosenworcel was able to pick me. And but the work of the TAC goes on. It's been such a great thing for me, and I'm grateful to everyone here for doing the great job that you've done. So thanks. Any other comments, questions? Okay, well then I think we can adjourn ahead of schedule, which is a great way to leave. Happy New Year to all of you, and again, great working with all of you. Thanks so much for another great meeting.